Hi, I'm Leandro Facchinetti, and let's talk about code, not necessarily write code, but let's talk about code today. And with me here, I have a very special guest. I have two special guests, but you can only see one. The other is on the call, but is not on the screen. But we have Justin here, pointed to the wrong side. We have Justin here. How are you doing, Justin?
Good, thanks.
Yeah, in case you were wondering, last week I didn't stream. I was sick. It was not COVID. It was not COVID. And we are back. We recovered. The whole family was bad. The whole family has recovered. And I was looking forward to this day for a long time now. We are going to dive into the ReEQ code base. And in case you don't know this, if you're watching this, you probably know this. Justin is the author of ReEQ. So we are going to go into the code base and talk about filters and oversampling and graphical user interfaces. It's going to be a lot of fun. So, Justin, I thought we could start with last time we had you on the stream, it was over at IDDQD Sound, and we talked about the origin story of ReEQ. And the impression that I get is that you are not necessarily designing filters, you are just taking the existing theory, packaging it in a great user interface, and then sharing it with the world. So I guess my first question is, how did you come about the filters, and how did you select the filters that exist in ReEQ?
Right, okay. Well, I mean, when I first initially started ReEQ, I started from a position where I was a fairly seasoned programmer, but not in DSP audio. I mean, my area of speciality way back when was in kind of graphics processing on that side of things. So there's some crossover, but not an awful lot. One thing that is common between sort of graphics development and rendering and so on and audio is the performance, the emphasis on performance rather. So anyway, with that in mind, I was sort of experimenting a lot with REAPER, finding out that you could program in it, buying all sorts of plugins, having a lot of fun with plugin synthesizers, just having a great time learning about the plugin software and the audio sort of sound generation world. And I don't know, I just got carried away in REAPER. I thought, right, wouldn't it be great just to maybe. I know what these filters do. I had to play with some of the, existing things like the Fab filter, Pro Q, and so on and so forth. I thought, well, let's just program a low pass filter just to cut frequencies out, high frequencies. And so I just went on an absolute Google marathon, really, which was taking me to the KV audio sites, to the fantastic REAPER JSFX forum, which is an absolute goldmine of information, and then of course to the huge code base that is the JSFX, which is just full of absolutely wonderful DSP nuggets. And I really took it from there. Obviously the first filters that I came across were the RBJ cookbook biquads, because they're the most common prevalent ones. And the initial implementation was with those, and then after digging a little bit more, I came across Andy Simper's SVF formulation, which made a lot of sense. I got my nose into the papers that he'd written, and still again climbing a fairly steep sort of learning curve to understanding how things map from S planes and Z planes into the actual sort of frequency spaces and so on, that sort of thing.
Yeah, so let's start with the basics then. Where in the code base for ReEQ is the implementation of SVF? As far as I understand, you're not using my library, right?
Well, of course, if I was starting ReEQ now, I might well use your library. But here we go. It's in this file here called SVF_filter. It's gone through a bit of name refactoring of late, but this is what it's called now. And I give a link at the top to Andy's paper, and it's all due credit to him. The formulations that are used in this are the ones that he came up with, which in some ways are easier to understand than the RBJ biquads. And as you know, we've talked about before, they've got certain benefits over the cookbook biquads. So I thought, yep, why not? Go for these. So that's what I did.
In fact, you are leveraging some of these benefits, one of which is that you can automate parameters and the filter remains stable. So you can morph between a low pass and a high pass, or you can do a filter sweep. And your implementation, unlike the paper, has all these extra features in there. So first of all, the implementation of the filter themselves, did you do something besides the paper, or is it just these extra features around? Did you find any mistakes or anything that could be optimized in these papers?
No, I mean the paper is pretty. If you sort of go to the end of Andy's paper, the one that I linked there. In fact, we can probably just bear with me. We can probably quickly create a browser under here to get it and bring it over here. There we go. Can we see that?
Yes.
Yep. Let me just. There we go. There. So I'll take that back over there. There we go. Is that all clear? Right. So, I mean, this is the paper in question. This is the one that sort of got me intrigued in this particular way of doing it. And the interesting thing is all this sort of thing that we see here is kind of, it's almost like pseudo-code in itself, really. And it just looked on the face of it, compared to the RBJ biquads, which are biquadratic formulas, this just looked a lot more easy, sort of more comprehensible. But it looked more familiar. Okay, we've got direct correspondence to certain shapes or characteristics of a filter, and there's not a lot of specification to it, really. It's which is common amongst SVF sort of formulas, but it's a lot easier to sort of get your head around, or at least it's not as abstract as a couple of biquadratic formulas.
One question I have about this paper is, when I was reading it, I skimmed the whole thing, but really I implemented the thing at the bottom, and that algorithm is a single thing that implements all the filters. But as far as I understand, the other versions that you were showing above in the paper, they are like for low pass and high pass. And I suppose that if you implement if you need a low pass filter, and that's all you need, and you implement that version, I think it's a bit faster. It saves a couple operations, not too much, like an addition and a multiplication maybe, but it does save some things. Did you implement this version that we are looking at right now, or the versions above?
Well, I wanted all of the. Well, the thing is, once I thought, oh, you know what? I instead of just doing a low pass, I could do all of the filters. So I actually needed all of the filters straight away, really quickly. So it was mostly a case of going to this part that I'm showing now and going, right, I can just implement those.
Okay. I'm asking that because I think that maybe in theory, in ReEQ, there is no way of morphing filters, right? So you pick a kind of filter and that's that.
Yeah.
So in theory, if you implemented the versions above that, maybe slightly faster. I don't know too much about that. I haven't really benchmarked it myself, but supposedly it is faster. Then that could be just give a bit of an edge in terms of performance.
It could do. It could do. I mean, you'd have to see. I mean, it's you'd have to time it or find some way of timing it in JSFX, I think, to prove it out. There's a lot of other things in JSFX actually, which we can probably talk about at some point, which can trip you up and really, negate any kind of missing a multiplier or an addition or optimizing that way. There's a few other things that can really just overshadow all of that from a performance perspective. But
what are some of the landmines that you know of already?
Well, one of the big ones is array access. That's one of the big ones in JSFX. I'll be able to, if we get through to the ReEQ at sample section, I'll be able to talk a little bit about that and what my kind of solution to it was at that point.
I see. I'm interested in that because in my library, one of the fundamental things that I'm doing is I'm doing a lot of array access. And that is a trade-off between performance and flexibility. You can do a lot more if you let variables live in arrays. In terms of you can put filters in an array, which is not something that you can sort of do with the alternatives. But we can get to that when we reach that part of the code base.
There are trade-offs. There are definitely trade-offs, which we can talk about. But anyway, coming back, I mean, this is what I implemented, and it was a lot of fun. I mean, you know, they're relatively simple, but to put them in and then try them out, and you can see the actual, you know, feeding noise through it, you know, which is the only way I could see it at the time. You know, you could see all the filters doing what all the filters were supposed to do. You know, the bells, peaks, notches, the shelves being shelves. It was, you know, tremendously satisfying earlier on to.
What is up with what is up with there is like a peak, and there is another one that is very similar. I think it's the bell, and I couldn't really understand the difference between them. And both tried to explain it to me, but I couldn't really understand it. And by the way, this is a great time to introduce the second person, my second guest, which.
Sorry about that, Leandro.
Yeah. Hello, Bo. How are you doing?
Hi. How are you all doing? I'm fine, thanks.
Yeah, so maybe you two can team up and explain to me the difference between peak and bell, because I couldn't really understand it. And I think that in ReEQ, there is a filter called peak, but it's actually the bell, or vice versa. I don't really remember, but
yeah, it's a bit confusing. And I was, you know, it's a long time since I've had to think about it. Let's see, we could probably just work out what it's doing from the code.
Well, peak has a sharper kind of not notch, but a sharper edge, and the bell is a more curve. So that's the end result. What the actual code is doing, that's not my area.
No, so it could be that the difference between them is that one of them is adjusting the Q value over amplitude, which seems to be the case. But I'm just trying to figure out which one's doing what. So if we look at bell, you can see here there's a K, which is introduced as a coefficient, which is implementing the Q factor in these A1, A2, A3 coefficients, or A1 in this case. But it's using the amplitude as well. So 1 over Q times amplitude. So Q is the actual resonant Q value that's fed in. Amplitude is converted here, if we look, and there's a similar thing in the shelves as well. It uses A as well if you look at the shelves, just for the amplitude there. So bell is adjusting the Q over what is essentially the gain, the way that where you move a node upwards, that's essentially the gain.
So in ReEQ, there is this filter called peak, but actually it gives you a gain knob, so it's actually the bell in the paper.
Yeah, I think what it is bell is retaining the shape of the sort of bump, as it were, as you raise the Q, whereas peak doesn't.
Yeah, is the notch related to the peak code-wise?
Let's have a look. No, not really. Notch is a funny one because it essentially bottoms. It's like a black hole. It just sort of bottoms to infinity in the middle. But that's the difference. So what I think it is, I think bell tries to retain the shape. So when you're raising in a bell curve, when you're lifting it up, it's kind of expanding out Q as well to retain the shape, whereas peak just kind of, well, it doesn't do that.
I see.
It's yeah. I mean, you know, did you put both in your SVF library?
Yes, and I played around with something that you mentioned, how you used white noise to see the filters, and these days you can use things like Plugin Doctor.
That's
But one of my favorites actually is this thing called Burton EQ Analyzer, because it's a VST. So Plugin Doctor is a host. You have to load a plugin in there. And with JSFX, it can be annoying. But with a VST, you can just drop a VST. You do a sandwich of VSTs and you put your plugin in the middle. And it's going to show you the response of that. And that is kind of cool. And I did that with the peak one from the paper, and it kind of looked like a bandpass. And I was like, but there is already a bandpass, so I don't understand it. But it's in there. I implemented it because it's in the paper. If you need it, it's there. And I don't know exactly.
Did it look like a bandpass? Because there's two kinds of bandpasses, I think. There's a bandpass that stays kind of with no gain at all. It's just a skirt that moves like this along the sort of zero line. Then there's another one that actually you can move around. So there's two different kinds of bandpasses.
Yeah, I don't know. I don't know which would. I don't know which would be the which in the RBJ filters. There are two kinds of bandpass. There is a constant skirt and constant gain. I think, if I remember correctly, yeah, something like that.
Yeah. Right. Okay. But I think, yeah. I mean, that's the way that you tell it. Really is. Yeah, just to use the curve analyzer that you mentioned and put them in and alter the values about and see what it does. But that's what I think it's doing. Bells, it's using the amplitude, the gain, to affect the resonance.
Yeah, and that's what we usually associate with a peaking kind of filter. Yeah. So my next question about the implementation of the filters is, you have to remember some values for the next time. So you have to remember the coefficients, you have to remember the previous IC1 EQ and IC2 EQ.
Yeah.
And then for people who are following along the development of my library, the way I do that is with what I'm calling real objects. I just store things in the memory, and you are not doing that. So how are you storing those values? What is the kind of organization or data structure that you have? Because I'm asking that because you have an include file. We are not in the ReEQ.jsfx file. We are in the SVF filter file. So that is kind of a library that you could reuse in other plugins. In fact, you do use it in the ReSpectrum plugin. So
yeah, it's there to use.
So how are you storing that, and how do you use the library, so to speak?
Right. Okay. Well, let's check it out. So if we let's have a look. Let's get some code that we probably recognize. So, for example, we've got this SVF single high pass. Now, it's worth mentioning the code that I've got in this library isn't quite as straightforward as it might be. Because I've actually extended the concepts to accommodate cascading filters, which means that we see a lot of this sort of thing, which is, I mean, I can sort of go into that, but if we just focus on the single ones now, which are this is the sort of thing that we're recognizing from the paper, from Andy Simper's paper. What I'm actually where I'm actually storing, in fact, we'll go right to the bottom where it's actually making use of these. So you can see for each of the filters, I'm using this sort of thing, which is the instance. So it's REAPER's kind of poor man's object system, which I know you've got certain opinions on.
I think they're great in terms of performance, and I think that they are great. And they are pseudo objects instead of real objects for performance reasons. That is pretty clear. But they are limiting, and they lead to code repetition, like you showed above. So yeah, it's a cute little trade-off that we have in our hands here. And I'm looking forward to exploring these other parts of the spectrum, but I am confident that my plugins will be at least 2 times slower than the average. So I do have some ideas that I may run by you.
Yeah, absolutely. Well, it really only kind of matters the most when you get to the @sample section. Everything's kind of okay. You've got, Brian, you've got a reasonable machine, which most people's machines are reasonable these days. You're okay, but it's just the @sample thing where you've got such a limited amount of time to get the work done. That's where it matters most. But nevertheless, but you asked where I store the IC1EQ and IC2EQ variables, the history variables essentially, and they're stored by way of the pseudo-object system in JSFX.
I see. Do you know what IC1EQ and IC2EQ stands for? I really wanted to know that.
I might give it. Well, it's a good question. You use them all over the place. I don't know. I could guess IC, integrated circuit, maybe.
Because it's using integration, trapezoidal integration. That's the method.
Yeah. That's right.
That just I think that's the method that Andy is using to go from the analog ideal circuit to the actual code.
That's right. It is. So anyway, I mean, the best example of the use of this library, because most of this library, was written really as a companion to ReEQ. So really, the best documentation for how to use this library is by looking at how it's used in ReEQ. I mean, when I've sort of written this, I kind of based it on an existing library, I think, and then it just took on a life of its own, and now it's quite different. Which was one of the I can't remember who originally did it because it's quite different now. But
was it in JSFX or was it in like C++?
No, it's JSFX. It's one of the JSFX libraries.
I see.
Was it one of Tails' libraries or?
Yeah, I was thinking that. Was it Tails? Because there's the Ajax and the Tail and Mr. Tail, Theo, are the big ones, aren't they?
In fact, until recently, I was using almost the identical RBJ one that he did. But like I say, this one took a life of its own because it changed quite a lot due to the cascading filters and so on. So it's probably, I don't know, it's probably worth talking about. Can we maybe talk about the cascading filter concept?
Yeah. Tell me more about that. I do know that the purpose is to have filters with different steepnesses, like a regular filter, if you just take the paper out of the box and you implement that, it's a 12 dB per octave slope. And you want the slopes to be like from 12 to, I guess, 96 in ReEQ, or maybe even 120 or something. Yeah, so if you're just talking about the slopes of the filter, which is essentially the poles, whether it's so 12 dB is 2-pole, 24 dB 4-pole, and so on. It is possible to design filters that aren't cascaded, that have just got more poles, essentially, higher pole filters. But as you've probably read in various places, you can come into stability issues. The more poles you add, the more unstable the numeric system can get. So one way around that actually is to just stick with say 2-pole, which is rock solid, and just to essentially layer them on top of each other to run the code through more than once, which is what cascading is essentially. I actually have a question about the stability of filters. When people say that a filter is unstable, it just means that it will start ringing and it is the samples are going to go beyond 1 and -1. So is it because of floating point errors? Floating point numbers are not perfect numbers. They have a little bit of error every time you do an operation, or is it something else? Is it deeper than just floating point operations? That's a good question. It's a good question. I think well, from what I'm aware of, I think it is because the numbers can get so small and outside the range of where, well, it's doubles in JSFX, so I don't know how far they would get being unstable there. But I think they can still blow it out. I think you just have to add more and more poles, and eventually, you're going to hit the outer regions of what those numbers can hold. Has it happened to you? Did you implement the RBJ filters and automated the parameters so fast that you could get one of them to unstabilize? No, I didn't actually blow out. I mean, the thing is, in JSFX, you get a big kind of hand up to start with, because all numbers, in fact, almost everything is a double, not a float. So it's 64 bits straight away. So that gives you a lot of playroom. Whereas if you to develop, outside in C++ or in Juice or anything like that, then you could quite easily just start using floats and come up against some
serious issues with that further down the road. I mean, for example, there's some of the other things that I'm experimenting with at the moment is analog modeling, sort of ladder filters and so on, Moog style filters. And for some of those, you have to oversample because, again, you can come up against numeric instabilities without oversampling. So you can reach those. You certainly reach them in analog modeling. And I think as you increase the poles significantly, I think the steepest ReEQ filter that I put in through Cascades was 120 dB Butterworth, that sort of thing. And I'm not sure if you would get to a point where that would blow up. I mean, certainly if you started moving it around and going through all sorts of numeric variation with it, then it could quite easily sort of blow up.
Mm-hmm.
What is it that's happening audio-wise when as the filter is blowing up? Because this is beyond me. What's apart from
it's kind of unpredictable. It's like you're in the realms of undefined behavior. Things, the wheels are just falling off. It's just who knows? You're just going to get bad things happen.
Okay.
You'll maybe get
like a crazy resonance or something, or.
Well, it could just crumble, collapse. You'll get clicks and pops. It just won't be very nice.
All right.
Yeah, it won't be good. So try and avoid that.
The cascades are for low pass and high pass, so you can get steeper curves. But do you have cascades for other kinds of filters as well?
Yeah. So the obvious, like you say, the obvious one was for the cutting or the passing filters, where you want a more extreme slope, that sort of thing. And that's what I originally put the cascading feature in for. It's kind of like a recursive sort of cascading feature to these filters. But after I'd done that, I thought, you know what, each filter can potentially have another bunch of filters associated with it. What else can you do with those? We can use them for different sort of things. And that's where I got the idea of doing, so for example, the tilt filter. That's essentially a cascade of two filters. The Pultec style thing that I put in there. The analog low pass and high cut. Basically, it means that you can sort of combine a few different filter shapes as well, piggybacking off the cascading code, and come up with interesting sort of filter shapes. So that's what I did with those.
And how did you tune these things? Did you find other papers that talk about the Pultec filters and tilt filters, or did you do it by like seeing what other people were doing and adapting?
Yeah, well, the tilt filter was straightforward. I'd already come across a way of doing that, which is using two opposite sort of shelves. So that was really easy. That was an easy one to put in. The let me see, the Pultec one. I'd had a play around with DMG Audio's Equilibrium, which features a Pultec sort of similar thing. And I've also got a couple of Pultec emulations. I've got the Waves one and Acoustica Audio one and so on. So I was actually looking at the curves that they were producing. So, for anybody that doesn't know, the Pultec trick is a low shelf that dips at the bottom of the shelf. So the idea is you can increase bass and cut out boxiness at the same time. So it's like a bass enhancer. So I just generally looked to the shape that I was getting through in the emulations that I've got, and just use them as a rough guide on where to attenuate a peak, a dip essentially, which is a negative peak curve, and what to do with the shelf and where that and how they should interact with each other as you raise the shelf and the dip comes in. And I just got a feel for it really. It's not. There was no scientific sort of breaking down of Pultec circuit diagrams, if that's what. It was just a case of getting it so it kind of looked right and sounded good and was useful, and there you go.
Yeah,
so did it by ear, really.
But the two-pole filters are not the only kinds of filters in ReEQ. There is also a 6 dB per octave slope, so that's a one-pole kind of filter, right?
Yeah, that's right. So. One-pole filters are incredibly sort of useful. Let's see if we can find where the one-pole. It's one of the sample rates. There we go. This is the one-pole code here, which is completely different to the SVF. It's it's more of a sort of conventional way of implementing a filter, a one-pole filter. There's only so many ways of doing it. But all we have there for a one-pole is low pass and high pass. And really in ReEQ, the main use of those is in the cut filters. So that you can go from 6 to 12 to 18, through 24, 30, so on, that sort of thing. So you can increase in 6 dB at a time, just to give you a finer granularity on the steepness of the cuts.
In fact, I was looking at an EQ this week. I forget the name, but they had a really cool feature. You could smoothly go from 0 up to, I guess, 96 dBs per octave. Mm-hmm. And I have no idea how that would work. I only knew of filters that would go in steps of 6. Do you know what is the magic there? I think it's the only filter.
Hofa filter, Hofa something?
Something like that, yes. I'm going to find the name and put it in the conversation below in the chat.
Yeah, so I can tell you exactly what's going off there, because I've implemented something similar on an analog modeling filter. So the way that it worked there, and the way that it might work in ReEQ, it's a tantalizing aspect, actually, I might be able to put it in, is that it's simply so if you think, so where I've implemented it is in a ladder filter. So a ladder filter works by having up to, say, 4 stages of 6 dB filters, and the resonance kind of done through feedback, because 6 dB filters don't have resonance. But nevertheless, the way that it works, so that you can smoothly go between 6 dB and 24 dB, is it just, again, it's a filter cascade of 6 dBs, but it kind of blends the result of them at the end, depending on what the slope setting is. So I'll give that some thought, actually. That might actually be doable. I mean, I still have it so that you select in 6 dB increments from the menu, but if you're using the keyboard shortcut to go through those slopes, there might be a way of doing it. Yeah, I'll give that some thought, actually.
But in essence, it's still a cascade. It's just you are mixing the cascade.
Yeah.
In well, not just by adding or removing one of the filters in the cascade, you are blending or mixing in the filters with different weights.
Yes.
Interesting.
Yes.
Okay.
Yeah. That's what's happening there.
Tuning that can be interesting.
Yeah. No, I might have a play with that, actually, to see if that'd go into ReEQ easily enough. Quite nice to see. Yeah, a sort of smooth interpolation between the sort of slopes. That'd be kind of really cool. Yeah, so that's good.
Right. Yeah. So, cool. And where do you get the code or the formulas or the idea for the one-pole filters? It's not in in Andy's paper.
No, it's not. He doesn't address one-pole filters at all. I mean, one-pole filters. I mean, you can just sort of Google one-pole filter, and it's just the most common filter you can. I mean, there's a really good audio programming book by a guy called Will Perkle. I don't know if you've got this on your shelf, but that goes through all the different filter types, starting with one-pole filters. Mm-hmm, but they are a tremendously useful, core foundational sort of building block of DSP. So yeah, really worth having in your library. And there's hardly any code to them, but they're used for everything from, I mean, I use them to affect, the 12 dB increment sort of slopes of ReEQ filters, but they're used for smoothing parameter updates and all sorts of things, for getting rid of, as DC blockers. There's all sorts of uses of them.
Mm-hmm,
mm-hmm. Yeah, I just wondered if from all the different sources you had like a canonical source, same you have for
the SVF. It's that. Yeah, they're almost one of the first things that went in, and I can't remember where the particular formulation that I got it from, although it probably wouldn't be hard to track it down. Let's have a look. Where's the? Yeah, I couldn't tell you. Yeah, it's lost in the fog of time, that one, where I got that from.
Sure, and
yeah, it's simple.
Okay, so we talked about the origin story of the filters, and Do you want to move on to like maybe your extensions, how you are implementing the interpolation, and I guess you have other extensions as well?
Well, it's probably worth talking about the Butterworth filters because they came along, you know, a bit after all the other filters had gone in. So I kind of read up a bit on Butterworth filters, and I liked if you look at ReEQ's normal filter slopes in the cuts, they're kind of cool. But when you start cutting, there's a fair bit of space between, you know, the sort of passband sort of top, and you know, it sort of increments as the filter gets steeper. Whereas the nice thing about Butterworth is I think it stays at a constant 3 dB or whatever it is, which I thought would be really cool to have. And again, it turns out that those filters can be implemented with biquads. So I thought, well, in that case, they can be implemented with SVFs. So I went on a bit of a mission to find out how to do that. And all it was really is that I found a source that said you can take a bunch of you know, 2-pole filters, cut filters, and by adjusting the Q values of each of those cascaded filters, depending on what kind of slope that you want, but it's the Q value which is adjusted to keep the 3 dB sort of drop at the passband. So that's it. So if we look at the code for that, I think it's there we go. That's this bit of code here. So it's computing the Butterworth maximal flat Qs for cascading filters. So make sure the drop at the cutoff is always 3 dB. So I can certainly tell you where I got this formulation from. So this is from what's the fella's name? His blog's called Ear Level. I don't know if you've come across it.
Okay, I will put a link in the conversation.
Nope.
Yeah,
haven't heard it.
Ear Level Audio. He's been quite active on some of the KVR audio forums, if you go sort of digging about in there. And he's done all sorts of, when I was doing the wavetable stuff, his was the first bunch of material I came across, and I had to sort of implement them in a useful way. But one of the things that he's done a whole load of blogs on filters and types. And one of the things he does is Butterworths, and he actually gave he had a JavaScript thing embedded on his website which calculated Q values for Butterworth filters coming from 12 dB 2-pole filter slopes, and I literally just grabbed it, which is what you see, which is exactly what you see here in the code,
as one does.
Yes, and that's it, and it worked perfectly. So again, what it's kind of doing is, I think this is working in the S plane, I think, and it's just adjusting where the, you know, the Q, it's getting the Q positions based on where they need to be positioned in the S plane, just so that the formulation of each Q value for each cascade will always sum up to keeping a flat passband with a 3 dB drop. That's what it does. But it was just one of those things, rather than a Butterworth being a exotic kind of formulation in its own right, you can just get to it by you know, massaging Q values of 12 dB cut and pass filters.
Yeah, as far as I understand, the idea there is that the poles on the circle, the poles are going to be exactly on the circle, and they're going to be equally spaced. So I think that these cosines are calculating the positions of the poles.
That's right.
In that circle.
Sort of go around. Yeah.
It's just essentially dividing the circle a bunch of times and putting the poles there. But the hard problem here is how to go from the position of the pole in the circle to coefficients that you can use in the SVF filter. And I guess that's the tricky part that you figured out, or that this person writing this web page figured out.
Yeah, exactly. Which is, well, this is it. I mean, this is what we're seeing here essentially. I mean, that's it. That's how you extract Q value from that particular position. So, so it's working out the pole increment, which is how much it rotates each time, and then what you're doing there is multiplying by the cosine of which one you're on, sort of going down as you go around, as it were. And 1 over that, well, and 2 times that is essentially your Q value. That's it. That's how it falls out.
Yeah, it is beyond my pay grade to understand why this works, but I understand how it does.
Yeah, I think with a lot of this stuff, I mean, you know, this whole poles and zeros thing, it's kind of hard unless you've worked with it, I think, for a very long time and have done a lot with it. It's really hard to map in your head from one kind of space to another one. So, for example, with a filter, when you look at what the filters are doing in something like ReEQ, I mean, that's the frequency sort of domain, right? Frequency and sort of time domain. But where the filters are actually sort of specified and applied under the skin, as it were, with the DSP, it's in like a different kind of domain. It's just the sort of domain of poles and zeros, or ones and zeros, around, and it's, you know, it's a complex sort of number system as well. So it's not enormously intuitive. It's intuitive when you're using a visual equalizer like ReEQ or ProQ or DMG Audios or any of the others. It looks really intuitive, but the actual DSP behind it is not, unless you've got a really good understanding of how it maps right the way from either S planes or Z planes right through to the actual processing of the audio signal as it comes through over time.
Is there a basic explanation of that concept with the poles and the circles, and because I've only seen it briefly discussed in a video, but is there sort of a basic tutorial for that anywhere?
There is. I can recommend that book again by Will Perkle.
Oh, cool.
He goes right through first principles with it. But even then, it's something that you have to keep reading, and it's one of those books as well. I don't know if you've read them, where you come back to it sort of several months later and you read it again, and suddenly a lot of things are making more sense based on what you've done in the sort of passing time. So it's something you just have to keep going until you kind of get a feel for it and understand it, really.
Yeah, I can recommend a book too. I haven't read the book you're talking about. It's in my list, but I haven't gotten to that yet. But I read the DSP guidebook. It's an online book, and the latest chapters, like chapter 30, is about the S plane, the Z plane, and how to go from one to the other, and how to relate the transfer functions, the capital H function, how to relate that to the coefficients that we use when implementing when implementing the biquad, as we did with the RBJ filters, not with the SBF filter. That's a different beast, but
yeah,
I think it's a good explanation. I was able to follow that more or less.
Yeah. So yeah, I mean, what was that one called again?
Oh, it's the DSP guide.
DSP guide. Right. Okay. Yeah.
Yeah, I'm going to put a link to that in the conversation.
Sure. So the one I was talking about, I mean, this is the chap sort of site, is this one here, Designing Audio Effect Plugins in C++. It's pretty cool. It's a really cool book. He's got another one as well, which is about synthesizer programming, but it's the audio effect one that really goes through the filters. So that's worth a plug there, I think.
Cool. Sweet. Thanks.
Yeah. So where were we? Well, there we go. And, you know, after updating S-Plane to get all the Q values out based on, this sort of formulation, lo and behold, ReEQ had Butterworth filters. So that's where the Butterworth filters came from.
Right. And do you want to maybe move on to the smooth automation of parameters?
Yeah. So, so the other thing the other slight complication you get when putting filters in there is, and I noticed it straight away, is when I was starting to move the filters about with the mouse, is you get what's called zipper noise, which is like variable frequency kind of clicking sort of noises. And what's happening there is that I was recalculating the filter coefficients each time based on altering sort of frequency or cutoff frequencies, that side of thing. So what's actually happening is as you move the mouse around and you're moving the filter, is all of those coefficients being calculated again each time, being put through the filter, but it's quite jarring. There's no the filter like histories with the IC1 EQ2 and IC2 EQ and so on. They're essentially violated at that point because it's like it's like a flick book. You're just changing it from one place to another all the time, and that's when you get this kind of zip noise and these sort of pops and crackles. So that was a surprise to me, and then I thought, right, okay, well, what's the answer there? And I looked at what people were saying, and yep, sure enough, you've got to smoothly interpolate your filter code. So the idea is you drag it somewhere with a mouse, and then there's got to be a certain amount of time where the filter coefficients smoothly interpolate to be into the new position. And then while they're smoothly interpolating, the filters are actually being processed DSP wise, but because it's all a smooth kind of transition and there's no jarring kind of steps, then the result's smooth as well, and all the zipper noise disappears.
Great. So let me ask you this. There are several variables going on there, and to use the language from the paper, there is the IC1 and IC2 EQ. There are the M coefficients, and there are the V's. Yeah. So which of these, or maybe all of them, you are interpolating?
So the only things that needed to be interpolated initially, if you look at what actually defines the filter here, so the IC1 and IC2 EQ zeros, they're really like a history of the filter as it's been processed in time. What needs to be, let's see if I can pull up an example of filter. Here we go. So here we go, is a high pass sort of filter example here again. So really the only thing that I needed to interpolate initially was these filter coefficients A1, A2 and A3, and then the weightings of those M0 and M1 and M2. And my initial sort of programmer hacky idea was, well, I could just linearly interpolate those surely. And then I thought, well, I tried it, and it kind of worked, and it did work. And I thought, well, is that the correct way of doing it? Because, you know, it's can you really just linearly interpolate from one A1 to an altered A1? And it turns out, after a lot of research that I did, that actually that's fine. That it's especially with SVF filters, there's no problem doing that at all. They're perfectly stable doing that, and it works. It just works a treat. So bear in mind as well that you know, these movements are actually, all these interpolations are generally quite small over time. So everything just kind of stays together. I think there's, if I remember rightly as well, I think it's even okay to do it with biquads, which seems even more remarkable. But anyway, I did the homework, and the consensus was it was fine to do for SVFs, just to interpolate these coefficients.
I read somewhere that if you do that with the RBJ filters, they go unstable, but I haven't really done it myself. I don't know. Yeah, it's a bit of a mixed thing. I think I might have read something as well where somebody was complaining that they're, yeah, it's like if I think if the difference is too big, you can run into difficulties with biquads. Or maybe so if it's too fast, if you have some sort of, yeah, it's too fast. Yeah, then you can kind of get things going through sort of zero or whatever when they're not supposed to. Yeah. So it's a bit more problematic. But for SVF, I think it's fine. They don't suffer from the same issues. Yeah, as far as I understand from reading the paper, the SVF filters can be interpolated even at audio rate. So you could change the positions of the filters every sample, and it would remain stable, which is interesting, kind of cool. Yeah, it means at least that they won't kind of degenerate or blow up or produce not numbers, that kind of thing.
If you're doing it audio rate, again, if you're making drastic changes at audio rate, then you might end up with zipper or popping sort of noises, just because the change is too much. But I think generally speaking, if you interpolate and get that set up properly, it'll just be completely smooth. But it's all down to the implementation.
So I have a question regarding the SVF sort of implementation. I looked at a couple of analog filters. I'm not that good with code. I'm an analog kind of guy. But there's 3 different taps on the SVF filter. So you get a low pass, a high pass, and a band pass out of the same circuit. Right. So is that the same thing with the codes? You can essentially have a 3-band each EQ from one bit of code or one chunk of code?
Yes, you can. It's kind of like that. I think there's and I think Leandro is aware of it as well. There's another formulation of this that Andy Simper did, which shows that aspect off even more. But in these, essentially, it's the M0, M1, and M2 coefficients that are those kind of weightings of high pass, band pass, and low pass.
All right. So this would make a good sort of multi-band compressor, or the EQ for a good multi-band compressor would be an SVF filter, because the transitions between the different sections would be really smooth and really stable.
Yeah, are you talking about crossovers for sort of splitting crossovers? Yeah, you'd probably want to use another kind of filter for that.
All right.
I think it's called a Linkwitz-Riley filter that you'd want for that.
But Linkwitz-Riley is a version of Butterworth, though, isn't it?
Yes, it is a version of Butterworth, but it's got certain properties which means that when they sort of cross over, you don't end up with a. They preserve phase, essentially, is what they do. So.
All right. Cool.
Yeah. I mean, you could certainly get to them by cascading these, for example. So you're right, they're a kind of Butterworth. So you could cascade these, do whatever you need to do with the phases for Linkwitz-Riley, and you can use them as a building block.
Okay.
Yeah. I have some people here on the chat that I want to say hi to. Tommy is here, and Brown House Media LLC is here as well, and they have a question that is not about the code, but it's about ReEQ, so I thought I would ask. The question is, I've noticed that the grid lines on the Mac version of ReEQ are very bright and very white. Is there a setting I can edit to make them less bright or a different color? Or maybe that could be a good segue to dive into the graphical user interface part of the implementation.
Yeah. I'm not sure about the grid, because which bit of the grid are we talking about? The sort of Bode plot grid lines,
I suppose.
Is that what? Because I thought they were only like 1 pixel, but I might be wrong.
No, the interesting thing is they say the grid lines on the Mac version. So I suppose that they have both a PC and a Mac, and they tested, and it looks different. And that is interesting, because you are not able to tell in which operating system you are from JSFX. It's just not a feature. You cannot tell if you are on Mac OS or Windows. So it should be the same. It should look the same, right?
No, you can't. But you can check that. So, for example, we have got this. So you can actually check if the sort of retina mode that you're in.
Yes.
Yeah. And on Mac, I'm just trying to remember now if that carries on to high DPI display PCs.
I haven't tested because I don't have one, but my PC is not high resolution. But I would suppose that it would be there. So
yeah, I mean, let's open ReEPer. I'll take a look at ReEQ. Let's have a look at the lines.
No, and Tormi is talking about the thing that comes up often in the forum, it would be nice to double-click the horizontal line and enter the frequency manually with a numeric keyboard. Yes.
Yeah, I can explain a bit about that while I'm here as well. If I just do a new project,
it would be nice, wouldn't it? It's just that we have the wrong Justin in the call. We should have Justin Frankel in the call.
Yeah, he's the one. He's the Justin you should be having for that one. Definitely. Right, let's check it out. So this is what ReEQ looks like for me. I don't know if that's coming across, but I think we're on sort of single lines. I mean, they're kind of the thick lines through the middle, which is the sort of zero filter sort of response line. So was the fellow in the chat room talking about these kind of vertical logarithmic kind of lines or grid lines?
Yeah, I don't know, but if you want to follow up in the chat and let us know, then we can talk about that.
It's usually delay between was it 9 seconds something, or is it even more? So it will probably pop up in the chat.
Yes, there's a bit of a delay. Otherwise, the internet has to be super stable, which is never the case. So I do a bit of
so a quick one being that came up about the keyboard sort of thing. So you're right, it'd be great to click there, to be able to go click one of these numbers to enter it in. That'd be fantastic. However, there's no native, easy, straightforward way of doing that in JSFX. I really wish there was. You can get keyboard input and you can do certain things with it, but it starts to interfere with the rest of REAPER sort of kind of behind. So for example, if in one mode that it's set in, if I go and take over and write my own sort of keyboard input so that you start typing, and if you then press space, because maybe you were typing a name or a space for a number or something like that, then it would actually, that space bar key command would fall through to the main REAPER and start playing the track. So the key presses kind of fall through. Now there is a setting in REAPER that you can put in at the start here, which kind of gets keyboard focus. But then the problem with that is that it's an all or nothing thing. So the moment that you had ReEQ focused, the only way to get it to play your track would be to click off of ReEQ and then play. And when I did that, it just got really annoying to do. Ideally, what you want is a kind of is when you go to click and type a value, it's then that you want to grab all of the keyboard focus till you've done entering the value, and then give it back after you've entered the value. But there's no way of doing that in REAPER at the moment. There's only like a global kind of setting for it, as far as I'm aware.
Yeah, and it's not a big surprise that this is the case, because JSFX were created to do quick scripts, and then people did some cute graphical user interfaces, maybe to show gain reduction or something like that. And then you come along and you create this. And of course, you're pushing the envelope on what can even be done in terms of user interface.
I mean, the other thing working about where I sort of pushed it as well is if you look at these sort of menus that, sort of come up, and when I put those in, they weren't actually documented anywhere that you could use that. It was documented in the Lua scripts that you could do menus like that, but the equivalent thing in the JSFX was kind of like a hidden feature. So the idea that you can do this, and I can't remember what the thing was, but somebody discovered that you could do it even though it was undocumented. And I actually went out on a limb and thought, you know what, I'm either going to have to write my own menu system and render it and manage the state for it, or I could just kind of use this.
That's a clever trick, actually. And is it documented now? I don't remember seeing that.
I think it's accepted now. I think it's official.
No, but is it in the REAPER website documentation for JSFX?
It'd be in show menu. I thought it was now, but it's worth checking.
Yeah, I don't think
but
it's there. I think it's still a little secret of yours.
it's still secret, right? Okay.
Yeah.
It's incredibly useful. So otherwise, you have to write your own menu sort of rendering and state management and all the rest of that sort of stuff.
Yeah, it could be really annoying. I do have a secret about JSFX that I learned recently when I was reading the code for Super 8, the looper that comes with REAPER. So I'll share this. Maybe you know it, but maybe you don't.
Yeah.
So there's this hidden feature in JSFX that allow you to take any buffer in the memory and put that as an item on the timeline. In Super 8, that is used, it's a looper. So you record a loop, but you can take the state of the looper and put it in the timeline as media items. There is a hidden API to do that. And the only way to learn about it is to go to the Super 8 source code and find how the function is used there.
All right, is that function actually documented, or is it another hidden?
It's hidden. No, it's not documented. You have to go to the source code of Super 8. The only effect that I know of that uses this feature.
Yeah.
And you have to go into the source code there, and you have to find the place. And there is a comment like undocumented feature, smiley face.
Oh, there you go. Is that...
And Braun has responded that he means the Mac and the background grid. Go on.
The logarithmic lines. So it's already a single line. So I guess the only thing you could do is make it gray instead of white.
Yeah, I mean that's the other. I mean, it kind of is grey. It's certainly not bright white.
Looks pretty grey to me.
Yeah, it's pretty. Everybody's color setting is different. This is half the problem.
It says the background grid is fairly faint. On mine, it's very white. Okay, so is that a red nothing?
Don't know. I mean, this is the. Well, I mean, here you go. This is the function that does it. So.
So that's the place where you want to explore, and it is using the Retina setting. Yeah,
I do that all over the place because I mean I work on a 2-monitor thing, and my Mac monitor is obviously built-in laptop monitor is Retina, and then my Dell over here isn't, so I get to see it on both kind of resolutions. So I did manage to accommodate both Retina and non-Retina. But yeah, the color's a weird one, so I don't know. I just invite.
I don't have that kind of setup. I have separate computers that have different screens with different resolutions. So what happens when you drag a window from one monitor to the other? Does it reset the GFX X Retina variable, and you have to deal with that in your code?
Yep. Yeah, the variable changes.
Interesting. I didn't know that. Yeah. Okay, so if you all don't mind, I want to take a quick break because I am realizing there are clicks and pops, and I think it is because my buffer size is too small. So, and I could change the buffer size while streaming, but I bet that is going to damage the audio. So we are going to be right back. I'm going to increase my buffer size in REAPER, and maybe that will get rid of the clicks and pops.
Yeah, no pops.
Hello again. So probably the audio is a little bit better now. When you're streaming, you always find things that only go wrong when you are streaming. So yeah, probably the audio is not clicking as much now. The buffer size is 1024. Right. Okay. So we definitely moved from the filters to the graphical user interface, and I do want to dive deeper into that because, of course, the user interface is a big part of it. Yeah, go ahead.
Tormi is asking about the pop. Hang on. The menus in Lua. pop-up menu, or the sort of is that what they're called though?
Yeah, I think it's the same thing called show menu. It's in, you can do it in the Lua scripts for Reaper, but it was undocumented. I think it was undocumented for JSFX.
So it's in the Lua documentation, quite simply.
Let's have a look. Yeah, I still don't think they've officially put it in. I'm just sort of checking.
And it is kind of common when you go to read the JSFX documentation in some places, like the FFT, I think, or the discrete cosinetrons on DCT. In some of these, they say like, okay, here's the rough guidelines. Go read the source for other effects using this. Some of them written by Justin himself, so not Justin Johnson, Justin Frankel.
No.
So the source for the official stock plugins is kind of documentation.
Yeah, I think which is kind of okay, I guess. But you're right. I'm just doing a search now for JSFX and show menu, and I don't think it's.
Word on the street is that the JSFX engine is going to be open source in the near future. The language itself already is. If you go to the WDL documentation, it's the WDL library, they already give you the implementation of EEL2, the language. But the whole JSFX engine is going to be open source in a few months too. So all the hidden features, all the hidden features will come to light.
That is so cool. I think I caught a part of Justin Frankel's blog where they were really looking at updating the JSFX or the EEL2 compiler to work with the new M1 Apple processors, and that was kind of interesting. Because I think the naive Rosetta that was working would have made them much slower. So I think they were doing some work around that.
I actually don't know about this, but that's a very nice feature of JSFX. You probably are not as fast as C++. You'll never be. But when a new architecture comes along, you don't have to do a lot of work to port the code over. I mean, I don't think you can do any work at all. You don't have access to any assembly or any primitives or SIMD. So because you don't have access to these things, you just take the same code and you let Justin Frankel optimize it for M1.
That's right. It's in a complete sandbox. And it was kind of cool as well. So when ReEQ was first kind of, being recognized as a fairly heavyweight JSFX thing, it got some attention, and Justin Frankel sort of spent quite a bit of time on improving the load time of JSFX based on ReEQ, just because ReEQ was so big, and it was I can remember at the time it was taking quite a few seconds for it to load. And he just reduced it like next to nothing. He spent a few days sort of hacking up, improving the load times and the compiler times. And that was kind of really cool. And of course, everyone benefits. Every JSFX benefits from that. So
yeah, the unfortunate thing about this, well, at least until the engine is open source, is that we don't really have a solid model of efficiency. We don't know what is fast and slow, except for things that we run into.
Yeah, this is right. It's completely sandboxed. It's completely opaque. It's the way to do it is to think about it as like a completely separate, like sandbox sort of machine within a machine. It's like an emulator in a way, isn't it? It's like you've just got this address space full of doubles, a very linear way of accessing it without a great deal of memory management, so to speak, except for what you implement yourself. And then a kind of a C-like language to layer on top of it. I mean, what kind of might be really, really cool if they do open source it is if anybody's going to take up the challenge of improving and enhancing the current EEL2 specification. I had quite a few ideas myself after using it so much about what would improve it. But it'll be, by open sourcing it, it'll be great to see if what happens with it. Really well.
Yes, but I do want to ask something that I saw in the code while you were scrolling.
Yeah.
You turned off the denormalization feature, or anti-denormalization feature. Can you tell me about that?
Yes, I kind of I've had a bit of a backwards and forwards about the denormalization.
I saw that in the Git history.
Yeah, exactly. So so one of the things that I was getting on the forum is one or two people complaining that whenever the JSFX wasn't actually visible or something like that, it was kind of slowing down in terms of CPU usage. But when you made it visible again, it kind of that sort of went away. And the only thing I could really put my finger on is there's maybe something in the back code path of the JSFX sort of runtime that was not running the denormalization code properly, something like that. It's a stab in the dark because it's opaque, like you say. So what I did was, let's see if we can go to the sample section. Is I kind of did this. So I turned off the the official denorm, as it were, and I put this in place of it.
And does that work? I thought that the denormalization thing was a small random value, not a small fixed value.
No.
Sorry, but what does denormalization do?
Well, what it is, when there's the way that plugins work, there's always like a signal going through them. Yeah. And if it's going through like filters and things like that, then that signal can get pushed down in terms of numeric value, really, really small, to the point where it's essentially like denormalized. It's creating these like numbers that are too small. They're becoming not a numbers, essentially, that sort of thing. And that can really sort of glue things up in terms of the processing.
Okay.
Now, you could do it with random numbers, but if you think about what this is actually doing, it's always ensuring that no matter what's coming through, it's above this amount, which is still way, way down to the noise floor. You can't even see it. But it's making sure, in principle, unless you sort of point me wrong on this, and it won't be the first time I've been wrong, but in principle, it's making sure that the numbers that are flowing through the system never hit, never get dangerously low, as it were.
Well, I guess the thing is, suppose that SPL0 comes as 0. There is no audio going through the plugin, so it's 0. Yeah. And then you have your small value there, so it's no longer 0, it's that small value. But suppose that in the DSP you are doing something that is dividing by 2000, then dividing by 100, and you keep making the value smaller, smaller, and smaller, and then you accumulate it in IC1 EQ. Then you have a very small value there, and when you operate on that value, it could take this. So as far as I understand, correct me if I'm wrong, but I'm going to run this by you. My understanding of denormalization is that if you take a very small number and you operate on it, so you add or you multiply, you are going to go to another part of the CPU that handles any kind of number, but it's not as optimized as the part that handles the usual numbers. And that's what makes things slow. So you're going to get the correct value, but it is going to be slower, and it's not going to matter because it's essentially silence at that point. So the denormalization, as far as I understand, was supposed to be a random number, because if you are doing this thing that I mentioned, like dividing by 2000 and then making the number smaller and smaller and smaller, sometimes you may run into this slower path, but on average, the number is going to be denormalized or normalized. I cannot really get my head around the negatives on this, but it's a double negative.
Yeah. Well, it's one of those things. It's something I looked at way back when I did it, and I was looking at people in the forums and so on what they were suggesting that should be done about it. And it was kind of, and that's what I've kind of done, and it kind of made sense at the time. But it's one of those things that you're always learning. So I'll take on board what you said and go and recheck that it's the right thing to do.
But I guess the final answer is: did it fix the issue that people were reporting?
It seemed to. People stopped reporting it.
So there you go. It is the correct solution.
So I did a thing, and people stopped reporting it. So what do you know?
We don't need a proof. We need a test.
There you go. Proof's in the pudding, right? So
yeah. Right.
Yes. You can divide by 0 in JSFX, can't you?
You can do anything. In fact, I ran into an issue recently that is so fun. I was implementing pink noise, and I had a bug that I was trying to check the number of trailing zeros in a number that was 0. So infinitely many zeros, right? That's the answer. But I had a loop to check, but then my loop was terminating, and I couldn't really find the issue for the longest time because my loop was terminating. So loops are bounded. You cannot loop indefinitely. Even if you have a while loop, you cannot loop forever. It's going to be bounded at like 1 million iterations or something. So there is nothing that stops your plugin from running. It may be so slow that you are only producing a sample every second. I have done that, but it's always going to run. There is nothing that stops the engine from running. You can divide by 0. You can take a logarithm of a negative number. You can do whatever. It's just going to keep running and give you a nonsense value.
Keep on trucking. There you go. Yeah. Yeah, I suppose the thing is that the show must go on. That was one of the principles behind it. So that if your plugin doesn't work, then, well, that's your fault. But Reaper's still got to continue, doing its thing.
Yeah, it's very brave of JSFX to do that. I mean, it could find that there is something wrong here. Let me turn off or bypass this effect. But no.
You're right, actually. I mean, maybe that would have been a better... But but originally some of these principles were thought of a long time ago, and maybe they do it a bit different now. Maybe not. I don't know. There was another thing on Justin Frankel's blog as well about a very similar thing. It was there's one of the inbuilt JSFXs for Reaper. I think it's one of the compressors. Is it the 1179 compressor, something like that? 1176. And there was. 1176.
It's based on 1176, but in Reaper it's the 1175. Yeah.
1175. There you go. That's the number of it. So in his blog, he said there was a bug that had come up in it where it didn't work in different sample rates, and apparently Dan Worrell had reported on this.
Yep.
In a video, some strange behavior with it, and he went in there, and there was just a weird multiplication in there, multiplied by 2 point something or another, and it was. And he remembered back from God knows how long ago when Reaper was first, when literally JSFX was first a thing. He'd gotten the log function completely wrong. And what had happened in the intervening years is it had got fixed, but now there was a load of JSFX out that came with Reaper that were working based on the wrong value of log. So he went through the JSFXs replacing what should have been a 1 log times another log by the value of 1 log divided by another log, and it was just because something had been implemented so early, and it had been implemented the wrong way, and then a load of code had been written that relied on it.
Yeah, and then it was like that for like 15 years.
Yeah, for 15 years pretty much, until somebody pointed it out, and then it's like, oh God, I'm going to fix it, But yeah, I mean, that's so. What I'm saying is, with a lot of maybe the design choices that have gone into JSFX, they're probably design choices that were made 15 years ago, in Reaper 1, something like that. So
yeah. And the language actually carries from the days of Winamp. EL1 was the language used to create those kind of graphics in Winamp.
Ah, I remember them, all the trippy sort of, the music.
Yep.
Sort of graphics.
Yeah, it's all legacy. Right. Okay. So I want to transition to something else related to DSP before we get back to the user interface. Sure. Talk to us about the oversampling thing.
Oh, this is a good one. Yes. So In fact, it's probably start off with I'll load REAPER up again, because it's worth maybe going into where the impetus from that came from.
And the oversampling is cool because it's one of those things that you want to get right, but in 99% of the cases, it doesn't really matter. You are not going to hear the difference. But ReEQ gets it right.
Yes, it does. It does get it right. I'm a stickler for trying to get things right. So imagine this: when I first a really early version of ReEQ, and it looked a lot more much cruder than this. But I was sort of, happily sort of, all right, great, filters. And then this kind of happened. Everything looks okay there. Kind of pushed. What's that all about? Right. And likewise, I shelf. Move this one away. So this sort of thing, where you can see what it's kind of. So what's happening is that the filter types are sort of changing shape as you get near Nyquist, which is half the sampling rate, so it's about 22,100, and you can see a difference in shape happening. And coming from a position where I was still learning a lot about sort of filters and sampling frequencies and all that sort of thing, it kind of came as a bit of a surprise. To say the least. I didn't expect it. I thought they'd just hold the shape like they do at this end there, like that. Now, what's actually happening at this end is the same thing's happening. It's just that it's happening in the frequencies that aren't displayed off screen. So what is actually the case is that the addressable sort of spectrum range from 0 to 22,100, if you're sampling at 44.1 or whatever, or 22 or 50, 44.1, is that it starts at the addressable range for filters starts at 0, and then at the end it has to drop to unity. That's the way that the math works. So as I understand, and I think I found this out when it was still biquads as well. This was before the SVFs, and so it's just simply the way that the math was. And then I went on a big sort of adventure trying to find out what to do about it, which is one of the solutions for it is oversampling. There are other solutions for it.
And do you happen to know why that happens? Why that is the case? I mean, why the cramping happens in the first place?
Yes, it's again, you have to go back to the sort of S-plane or Z-plane sort of space. It's just my understanding is, and again, it's not easy to talk about this stuff. My understanding is that the way that the maths work is with the poles and zeros is that, like I say, they just by the design of the filter, the way that they are, is they'll pull down to 0 as you sort of rotate around and go through the frequency, which means
when you say pull down, do you mean you don't mean the magnitude, right? Because on the shelf, it's not going to go back to 0?
No, on the shelf it doesn't. You're right. That's a good point, actually. I mostly thought about these things in terms. Let's get the shelf back up.
I have an intuition for this. I'm not sure that it's the right answer, but I do have an intuition for this that I want to share with you because maybe you can correct me. So in ReEQ, as far as I understand, you cannot show the phase, right? You can show the magnitude, and that's what we see right now, but you cannot see the phase that the filters are introducing, right?
That's right. So it retains it's about retaining the phase, right? Yep, go on.
Yeah. So can you maybe open ReEQ? Confusing names.
Yeah.
So on that one, we can see the phase, and I think that may be the answer. So there is a little show phase checkbox in the lower right.
Yeah. Lower right. That's right.
It's yes, that guy. Yeah, so you can see the little curve that is the phase. So as you move to the right, you'll see that the phase snaps back to 0. It always does. The phase is always at 0, even with a shelf. It's always at 0.
Yeah.
Regardless of what you do, whatever filter you do, the phase is going to be at 0 there. And that kind of makes sense because the phase is how much you are taking that the energy in that frequency and you are pushing it forward in time. You are delaying it, or you are shuffling it in time. That's what the phase is. So in 0 hertz, you cannot push anything forward because there is nothing to push forward, right? So the phase at 0 should always be 0. We cannot see that on that graph because, again, this graph starts at 20 hertz, but it is 0 at 0 hertz, or DC, right?
That's right.
Yeah, and the same is true of Nyquist. When we are at half the sampling rate, it has to go back to 0. Well, why is that the case? Well, because you cannot really represent the frequency at half of the sampling rate. And this is something that was confusing to me because I always thought, okay, I have one sample for the peak and one sample for the trough. So I can represent exactly the frequency. We are talking about exactly the frequency at half the sampling rate. So if you have 48K as your sampling rate, you can represent 24K exactly, right? Well, kind of. It depends. It depends. If you're lucky, you can represent it because your sample is exactly at the peak and exactly at the trough. But what if your signal just happens to be 90 degrees off of that? So you are sampling at exactly the points where the wave is crossing 0. So I haven't really read the papers by Claude Shannon and other people that talk about the Nyquist frequency, but I think that the Nyquist frequency is not an inclusive upper limit. It is an exclusive upper limit, or it may be inclusive if you're lucky. But if you're unlucky and you're sampling exactly at the 0 crossings, you cannot represent that frequency. So in essence, what I'm saying is you cannot represent the Nyquist frequency exactly. So you cannot push it forward because you cannot represent that. So how are you going to push forward energy in a part of the spectrum that you cannot even represent? Well, you can't. So that phase has to be 0. It's always going to be 0, regardless of what you do. You may be smart about decramping the filter without oversampling, which is like what the Fab filter Pro Q3 does, and some other filters do that as well. They do some weird phase mangling so that the phase is still going to be 0 at Nyquist, but before that, they reshape the phase response so that the magnitude kind of looks decramped. But it always has to go to 0. And that's why cramping happens. If you are not careful about the frequency, if you just do a basic decramping, because there is some basic decramping going on, even on the RBJ formulas. If you read that cookbook, they talk about unwarping the frequencies. And
so that's the bilinear, the BLT bilinear transform.
Yes.
Essentially using pi.
Yeah, you do have to try to unwarp the frequency, but there is only so much you can do. And you can go to the highest frequencies and try to de-warp even more. But the physics of the situation is the phase has to go to 0. That's why warping happens. And there are shenanigans you can try to pull with the phase to decramp, but it gets complicated mathematically. And as far as I can tell, it's kind of a trade secret of people who do it. There is no like cookbook that does decramping. And even then,
there's some information you get onto it because I looked into it a lot and I still continue to look into it. There's a paper by a guy called I think his name's Vikanek. Again, these are all kind of mentioned in that Will Perkle book, and he does go through some examples of decramping, which is kind of interesting. But the decramping that takes place in, say, Pro Q, or in particular, the amazing one is the DMG audio stuff, Dave Gamble's stuff. The filters in that, he provides elliptical filters, Chebyshev, the whole lot, and they're all decramped and they're all perfect. It's I can only imagine how difficult that was to do. But yeah, it remains kind of bit of a trade secret. I think it's just really hard stuff, actually. And it always comes at the, well, it can come at the expense of, like you say, phase. So you start really sort of messing with the phase, and then there are other people who have come up with derivations of it that actually use all-pass filters to try and correct the phase, leading up to the phase distortion. It's quite a, you know, it gets really involved really quick.
Yeah. So you don't know of any cookbook that does the decramping magic of these fancy filters?
So there's a paper by Vikanek which gives some formulation of how to do it with biquads for low cut, high cut, and bell filters. But I think it's harder again for the shelf filters. There's no derivation for shelf filters to do it.
Oh well, but that is kind of easy, because if you have a high pass and you add that to the original signal, you get a high shelf.
Well, in theory,
yes.
But I think in practice, because of the way that it sort of decramps, I think they're called Match Z. Match Z, I think, is the. Let's have a look. Neck.
And I find this fascinating because, like, 99% of the times you're not gonna hear the cramping. But then there is an easy, well, not easy, but there is a straightforward and very widely used solution, which is the oversampling that we are going to cover in a moment. And that is already unnecessary in most cases, but doing it with, and I guess the advantage of playing with the phase instead of oversampling is that you don't need any latency to pull it off. But that is like such an edge case that most people are never going to care about. And yet here we are chasing that. And I find that interesting. We really want to get it right.
Annoying that, yeah, it's just annoying that you know, it's so difficult and you know, and not exposed really. But here's the paper that I was talking about. It's from 2016 by Martin Vikanek. I don't know if I'm pronouncing his second name right, but Vikanek. And he goes into a method of he covers the other one that I came across before this was the Orphanidis peaking EQ, which is just for a peaking EQ, but it's how to essentially modify a biquad so that the Nyquist, so it doesn't drop to unity at Nyquist, it's kind of lifted up, is what he did. This is the sort of formulation for it. And then there's Massberg as well, which I think I only saw for a shell filter or a low pass. And then this is his work, the custom matched biquad. And if we go a bit further, then you can see on the right here, which is what normally happens. And then on the left is using his method of Z matched biquads.
I would like to see the phase response of that. The magnitude is kind of easy. I mean, not easy, but the magnitude is okay, what I would expect. But what is happening with the phase? How is?
It's gonna monkey around with the phase. I mean, that even happens in ProQ. If you look at the phase responses for those, it's definitely it's not. Yeah, it's affected.
Yeah, in the ProQ3 manual, there is a graph showing the phase, and it goes like, it is a bit weird, and then when it gets above 20 kilohertz, it gets like back to zero. Like they are like trying to push that beautiful shape that we saw in ReEQ when we were to the left, and they try to push that shape as much as they can, but the solution is that you kind of have to do a steep return to zero. It has to be zero at Nyquist. Yeah,
at some point, but anyway, I mean, so there's this page. So at first I was really happy when I came across this, and I thought, great, you know, maybe I'll be able to get to type some of this in. But again, there's no derivation for shelves, and I'm led to believe that shelves aren't trivial using this. And so that's as far as I took it, really. I do know that, so it's kind of interesting because, for example, in Melder's EQs, most of those actually cramp as well, apart from they've provided a variation of their peaking EQ, which doesn't cramp. And I wonder if they've just used the Orphanidis one or the one out of this paper, just for that one filter shape, which is the peak or bell filter.
Mm-hmm.
But I was kind of, I could do that, but I really would like, if we're going to do decramping, then they all need to decramp. I mean, the good thing is, if I could get all of my filters to decramp, then all the cascading would work and so on. Everything would just, it would just sort of click into place. Anyway, we're not there.
Yeah, so we are you have implemented the solution that most people use. Like even some big names in Ableton, Andy developed that paper when he was working on EQ8, and in Ableton in EQ8, the solution is just oversample.
Yes, so that's what it does. It's ×2 oversampling. That's where I first came across it, because originally one of the motivations for ReEQ much earlier was to make something that was at least as good as EQ8, and starting with Andy's filters was a big leg up, because okay, the filters are the same, but again, I was kind of surprised to go into EQ8 and see that, oh right, the way that they've corrected this is by oversampling. And then I thought, well, if EQ8 can oversample, then maybe I can go and look at what was involved with that. And that was kind of non-trivial as well, certainly at the time. I mean, maybe we can go back to the code and start looking at that.
Yeah, so there are multiple ways of oversampling, and they have trade-offs. Yeah. You can oversample in real time with no latency, and that's useful for things like distortion on guitars. But then if you oversample that way, there are some phase issues. And I think that the oversampling I guess you cannot eat your cake and have it too. I mean, there is a physics kind of limitation here that either you're going to play with phase or you're going to have some latency. And in ReEQ, you are adding latency, and you are doing it with a linear phase filter, right?
Yes. Yeah, so you're right. There's kind of two ways of looking at it. The first way is that a lot of the time when oversampling is introduced, it's to get rid of aliasing. So if you've got a plugin that's maybe a guitar amp plugin or a saturation plugin, that sort of thing, those plugins, left as they are, will produce generally a lot of distortion and aliasing, which is kind of these harmonics that are folding back into the audible part of the frequency spectrum. And so what oversampling, the idea with oversampling for those kind of plugins is that you up the sample rate, you run the effects internally, and then before so that when you go back to your normal sample rate, the things that are above sort of Nyquist don't fold back into the audio range, you filter them out and then downsample. So you kind of upsample, do your effect, chop off, or try and really, you can never truly chop it off, but really reduce the stuff that is going to bounce back, hopefully down to near the noise floor, and then you downsample. Now, and there's kind of two ways of doing that. You can either, there's two kinds of filter you can use, right? There's an infinite impulse response filter, which is kind of like the SVFs and the biquads and those sort of things, and Butterworths and Chebyshevs and elliptical filters, or you can use a fur filter to do it. So the difference being, which is what you were kind of saying, is that the fur filters are essentially linear phase. They don't affect phase. Whereas the infinite impulse response filters, they do affect phase. So if you've got a very steep, say Chebyshev 2 or something like that at the end, which is going to push everything down or attempt to cut most things out, then that's going to have a serious effect on phase. And what's kind of even worse about it as well is the steeper that those filters are, the worse they affect phase. And you can certainly get away with doing that a lot of the time for, like, saturation or guitar pedal simulations, that sort of thing. But for an EQ like ReEQ, where it's supposed to be transparent and you're supposed to be able to use it for mastering and that sort of thing, the last thing that you actually want to happen is for it to be completely messing about with phase and doing goodness knows what to the sound. So really, you know, I had to discount the IIR filters and go for a finite impulse response filter, or a FIR filter as they're called.
Yeah, so I guess the trade-off there is that you are now introducing latency. You do have to wait, I guess,
yes,
60-something samples for to be able to apply the filter. But also you are introducing some maybe some pre-ringing, or you're smearing the sound in that small window.
Yes, so that, I mean, that can happen with FIR filters. You can have pre-ringing, but it's generally, as far as I'm aware, it's only around the part where there's going to actually be where the filter's applying the cut. And so the idea with the filter that I use for EQ is that needs to be as high up as possible and as steep as it kind of can be practically, so that anything that could happen there is just so far beyond the human hearing spectrum that you just won't be able to hear it. The main thing is that the phase will be linear.
I see. Okay, so where did you get this filter from, and how does it work?
Right.
That is not part of the SVF paper that we looked at before. That is only for the filters, though Andy implemented some oversampling in EQH. I don't think that part is public, right?
No, it's not. No, it's not. No, it's not. So I spent a lot of time trawling the KVR audio forum and other forums. And in fact, the first filter that I did put in was actually was one of the filters that you would use for like a guitar pedal or something like that. And then much to my horror as well, a lot of those filters, they kind of start losing frequency after about 15, 17K, something like that. And I just realized, no, it's got to be right at the end. It's got to be steep and it's got to be linear phase. Otherwise, it's just not going to work. And that took me to FIR filtering. And I think there was a JSFX that I found by looking at the JSFX forums, which was actually a low pass filter applied. I can't remember what it's called. It might even be one that comes with REAPER. It's a FIR low pass, I think it's called. I'm just going to check it out. Just bear with me. And I think that's where I kind of started.
Sure. While you are looking that up, I do want to say hello to Daniel. Hello. Great to have you here, and thank you for the nice words. And it seems like the grid lines conversation that we were having, it really does look different on Brown's machine, Brown House Media LLC machine. So I don't know why that would be, but it seems to be happening. So,
well, I'm going to end up putting a slider in or something so you can alter its. I've actually seen that in a couple of EQs. Anyway, yeah, so noted. Right, okay. I'll put that on the list. Things to fix. Right.
By the way, since you mentioned the list of things to do, do you accept contributions for this project? Is it in a stage that people can jump in and contribute to? Do you have like a to-do list of things that maybe people can jump in, or is it in that stage where you're like cooking things yourself?
Maybe. Yeah, I mean, I've got my own sort of private to-do list of a scramble of notes and things that, you know, are going to come up and go through at some point. Although there's no reason now why, you know, it couldn't really be on GitHub and, you know, using the GitHub project system. And I mean, you know, the source is there and anybody's welcome to fork it. But yeah, I should probably get a little bit more organized and a bit more official with the whole sort of Git ecosystem.
Okay.
Yeah.
All right.
Then,
so without further ado, we do have the author of the code on the screen is here on the chat. So hello, TN, great to have you here. And I learned a lot from reading your code, so thank you for all you did.
Okay. Yeah. No, that's really, really, really cool. Well, I learned. I mean, I learned from this. I wanted to know about low pass windows, and this is where I was initially, where I found myself. And that's so this version's 2013 to 2017. Anyway, this is where I sort of got the general gist of it, really. I think this is using I think this one's maybe using an FFT. I mean, maybe it's the other one that just uses a fur to sort of cut it off. But anyway, it was a revelation to me that you could, do fur filters this way. And that took me, down a few other paths, sort of researching and so on. And that took me to, let's get rid of that, come back here. A reference here. Let's see where that. A refresher for me. There we go. It's a really good idea to put these links in your source code, actually, to sort of jog memory.
Yes.
There we go. This says it all, really. So this was a good reference. Yeah, I mean, we don't have to go into the details of it here, because I think if anybody wants to sort of check out this link, it's a really good article. And
I guess in summary, the essence of the thing is you have the impulse response of the filter, and you then do a convolution with the filter response into the signal.
Indeed.
Yeah, so it's the same as a convolution reverb, sort of, or a convolution to do a cabinet, to emulate a cabinet. It's the same story, but now with a filter. In fact, a cabinet emulation is sort of a filter, so that kind of makes sense. And the cool thing about that is that you have complete control over what the phase is going to be like. And in our case, we just don't want to mess with the phase. But if you wanted to do anything with the phase for effect, like in the Melda Production free bundle, there is this phase thing that you can draw any phase, and it's going to apply that phase to the signal. You can do that using convolution. And the cool thing about this is that you're just doing convolution, right? But one of the fastest ways of doing convolution, depending on your size of your impulse response, is to use FFT. So you do an FFT, you go to the frequency domain, then convolution in the time domain becomes multiplication in the frequency domain. So you just do a simple multiplication, and then you invert, and you go back to the time domain. So it kind of comes full circle.
Absolutely. So so this was a great article. I came up to speed really with this article and some of the JSFXs, like I pointed out. Let's move this out of the way.
But no. Before you do that, there is something really cool about that image. The filter impulse response that we have on the screen right there, it says plot of the impulse response for different values. That plot, you can see that it has sample 0, and then it has positive samples and negative samples, and that is key. That is why we need some latency to run this, because we need to remember, we need to apply the impulse response to samples in the past. That's the negative samples, that's all right. But we also need to look ahead. We also need to apply the filter, the impulse response to filters that are, to the samples that are going to come later. The positive in this graph, the positive numbers in the x-axis in this graph. And that's why the latency is necessary to run a fur filter. Yeah,
that's right. That's it. So that's where the latency comes from. But you're right early in saying that you can't really have your cake and eat it. You're dealing with either latency or phase response. It's and what you can do with those really. So certainly for an EQ that I was wanting to be transparent with a steep cut at the end, then it seemed like linear phase, and accepting a small amount of latency was better. I think it was unacceptable to really mess around with the phase and any kind of drop off in frequency that you might get at the end and that sort of thing. So yeah, the best way to get the steep filter that I was wanting was to use a fur. Now, the question then it came down to, well, what kind of, applying one of these is really straightforward. There's plenty of sample code kicking about in JSFX land to do it. So really the question then becomes, well, what does the filter look like? And let's see if I can pull this side up. Here we go. And this is the site that I used to design the filter. So essentially, the sort of filter that I ended up settling on after doing quite a bit of research is the Kaiser bezel filter. And really, it's as simple as, I'll say simple, it was a case of, putting these values in. And I think, did I actually mention, yeah, I think actually here are the operating sort of values, that ReEQ uses for that. So those put into this filter designer here. In fact, we could probably do it, couldn't we? Why not? So FB 22050, length 65.
So let's talk about what these numbers are. FA is the... what is FA?
0 hertz. That's probably the starting frequency. In fact, why is that not gone to 22050? Right, just bear with me. I think I need to. I think it depends on how you enter these as well. So set FS to 88200 because we're times 2.
Yeah. Okay.
In fact, let me just let me just move that over there so I can reference it at the same time. Right, so bear with me while I pop these in.
And while we are doing that, it's interesting to note that we are doing it backwards. We are starting at the end. We are now talking about the downsampling that happens after filtering. So you are going to do an oversampling on the audio coming in. You're going to apply all the filters that we talked about for the best of this stream. For most part of this stream, we talked about the filters, the SVF filters are applied at double the sample rate. Then you downsample on the way out using, and before you downsample, you have to get rid of frequencies above the Nyquist frequency of the target. So if you are going to downsample to 48, you have to get rid of everything above 24. And that's the filter that you use to do that. So we are starting at the end, at the downsampling stage.
That's right. So that's 96, nearly there, and we've got the exact filter. There we go. This is the one, this is the shape of the filter that kind of I was going for.
Okay. Yeah, it's steep and it has very little side, in terms of side lobes, they are very small. They are below 100 dB. So,
yeah, I mean, if we sort of raise that back up, you'll see what they look like as it's being pushed down. That's what they sort of look like. But I, you know, I really wanted them pushed down to what is an extremely sort of low range. But nevertheless, so that was used. So if you see here, FA, like we were saying, is the starting frequency, which is normally always 0. Then B is essentially the sort of stop band.
So this is not like a low pass. It could be a band pass. We could filter frequencies below 10 to get rid of any DC offset with a single filter, right?
Yeah. I don't know. Maybe you could get rid of. Yeah. I mean, if we put that to, I don't know, 1,000 like that. I mean, maybe it would. Oh no, it seems to want to be at 0. I've never tried it.
So there you go.
So I'm not sure why that is, but nevertheless, yeah. Anyway, there we go. So there we go. So what essentially this filter designer kicks out once you've designed the kind of filter that you want is these sort of FIR coefficients.
Yeah, and let's talk about some of the other input parameters like M. M is the size of your window. So now there is a trade-off between, I suppose, the quality of the filter and the number of samples. If you give it more samples, the number of points there is the size of the filter kernel, the impulse response that we're going to get out, which is also the number of samples that we need to buffer. So, or maybe half of that, but that is going to influence the number of samples that we need to buffer or the latency. So the bigger this M is, the better the filter will be, but you have to delay more.
That's right. That's right.
Okay.
That's the trade-off. That's the compromise.
Okay. And you have control over the size of the side lobes. You have control over the steepness of the filter too. Yeah, that's the number of samples there. If you have more samples, it becomes steeper.
Yeah, that's correct.
And how did you come about these values? Was it trial and error? Did you find these parameters somewhere?
Trial and error.
Fair.
It was a case of I tried out a bunch of different ones and then was trying to get ReEQ to null with a normal sort of signal. And if I didn't see any nulling, so difference in signal between ReEQ's signal and an inverse polarity other signal, I knew when I got it wrong because you'd started seeing some frequency representation at the high end. So the moment that essentially went to 0 and went way down into the noise floor, I knew I'd got the right kind of settings, the right value.
Yeah.
So there's a little bit of trial and error. It's a question of, right, what's the least amount of points I can have with the steepest filter that's got the noise, you know, the floor sort of push down qualities that I'm looking
at. The M is
So
actually, I guess, the only parameter that you can steal from EQ8. You can see how many samples EQ8 is holding on to, and that's your M, right?
Yeah, although I'm not sure. I'm sure there is a way of doing that in Ableton, but I haven't actually found. I didn't actually look into it.
Oh, it's very easy actually. You just put EQ8 on a track, and then you hover over the title bar of the effect, and it's gonna show you how many samples it has of latency.
Yeah. So
let's cross-check your answer. Let's see if you got it right. So when we started this last time, we talked about the origin story, and you mentioned that I asked you if you were in the business of designing filters, and you said that no, but actually you are designing filters.
Yeah, I mean, not new. Yeah, okay, yeah. I mean, the attributes of a filter, I suppose. Right, okay, so oversampling. Right, so what did you say again to get the
it's like right there, 16 samples.
16 samples, latency, there we go. It's at the bottom, isn't it? Yeah, I do remember that actually.
Yeah.
16 samples, yeah, there we go. Yeah, so that's EQ8. Don't save. Yeah, so anyway, so this is the formulation I ended up with. I think it is. It's a year or two back now. So I'm sort of dusting it off a little bit.
So what you do is you get the FIR listing, that's just a bunch of numbers, and that is your impulse response or your filter kernel. And then you paste those numbers there. And then how do you use the numbers? Do you use an FFT and do it in the frequency domain, or do you just multiply and do it in the time domain?
Yeah, so right, okay, this is an interesting one. So if you look at we can sort of look at the code and you can sort of see what's going off there when it's applied and so on. But if I go down to the bottom here, I'd noticed this the other day, I'd kept it in. This code at the bottom here is kind of like what I initially wrote. And so it's using a sort of history buffer, which is like a moving sort of history buffer that's applying the coefficients as you're going through time, and samples are being fed into that buffer. And this is the kind of well, not the longhand, actually, the shorthand for doing it. And you can see, in fact, there's a bit where I was reading it from the file there to sort of check it all out to make sure it was all sort of working right. So that's a bit of a progression in history there, right there. That's actually doing the convolving there, I think. Yeah. Now, where that eventually ended up is that is these bunch of functions. So at this point, so like I said, I've got a couple of functions there for initializing the fur coefficients, and then rather than doing a loop through arrays, which is what you'd normally sort of do with this sort of thing, I'm actually storing, because there's only about, there's only like 60 odd sort of values to store. I'm actually feeding them through set independent variables so that I don't ever have to access an array. Does that make sense?
Yes. How slow was the array version?
It was, again, this is going back quite a year or two now. It was noticeable. It was perceptible. I can't give you a hard number, but it was enough to make me think, right, how do I stop that from happening? So I came up with this, and so again, and of course, I think I was on a different machine then as well. So it'd be interesting to do some new sort of timings on it. But there's some more interesting details here. But essentially, this is why this code looks like it does, and it's not written as a while loop. Because what I think will happen is the EL2 sort of compiler will do a really, really good job of moving this about, of producing the machine code for this. There's no array bounds checks. There's no sort of looping going off. It's literally just shunting variables along memory location. So it does a pretty good job, I think.
Yeah, I think there is a limit to how good of a job it can do, because it is very difficult, almost an intractable problem to find SIMD over a loop. It's something that compilers do, but it's very difficult. And this is the best case scenario for SIMD. You definitely want to do this single instruction, multiple data. So I don't think that we can ever be that fast in not comparable to something like ProQ3, which is doing SIMD. So I don't know.
Absolutely, yeah. Yeah, and the thing is as well, ProQ and so on, they'll have, I mean, compilers can do it to a degree, but then, you can do it all yourself in SIMD, and you can take full advantage of it in other languages. So unless somebody came up with a JSF extension in future that let you support, multiple operations in one go, SIMD, then I think there's only so much that it could do automatically, definitely.
Yeah, I don't think we are ever going to get the best of the best performance, but it bugs me that we have to write code like this. No one likes writing code like this. Did you write this by hand, or did you write a program to write the code for you?
No, I wrote this by hand.
Yeah, so I guess we can sort of take this detour into my library that is trying to avoid writing this kind of code. And it's not the end of the world, but it does add up, especially if you want to do something like multi-channel. And I don't think that ReEQ is multi-channel. It's stereo or mid-side, but it's not multi-channel. So you cannot filter something 5.1. You cannot do that. And I find that it's kind of annoying, right? You could just loop over the number of channels and do multi-channel. You could just loop over the samples that you have there and apply the filter that way. In theory, it should be doable. And then my current solution for that is just store everything in memory and write everything using loops. And I know that that is slow, at least twice as slow. But the other idea that some people have had in the past is just have an extension of the language. Have some other language that you're writing, and that language produces JSFX. And that is like, you can imagine like a little JavaScript program that spits out text that does the thing that you showed us before. And I was maybe considering exploring that, because that would be the best of both worlds in the sense that it is fast as you can do it in JSFX, and it is not repeating code. The downside is that then you have to learn another language, so you're paying the price of programmer complexity. You have to think about all these meta programs.
Yeah. Well, this is it. So that's essentially, I mean, it's crossed my mind before, that's essentially a transpiler, right? That you're going from one language to this one, you're treating this as the lower level kind of thing. It's what a lot of languages way back when used to do, that, even like Lisp compilers did it to a degree. Some of them used to spit out C code, and then that used to compile and run. So you had the higher level languages spitting out the sort of lower level languages, and then, you know, that's ultimately what would then get again converted to machine code, and off it would go.
Yeah.
And I think Grant's done some sort of extension, some sort of macro processing on JSFX like that, if I remember correctly.
Yeah, there are two that I know of, and they address some issues. But the first issue that they all address, all these meta languages address, is the issue of looping. So the issue that we have seen right now. But at that point I thought, well, have I crossed the boundary? Should I be working in C and C++ instead? Because if I am in C++, I can just use templates and get out of here, not worry about it. So I don't know.
Well, we'll see. Well, like you said, they're open source in JSFX, so who knows what's going to come along? You know, you never know. But sort of coming back to there's probably one thing that is definitely worth mentioning about the way that the FER and the oversampling sort of works. So it turns out that coming back to the oversampling is, so our idea is that we're going to extend our frequency range by oversampling. We've got to upsample, apply the filters, all the shelves and bands and whatnots, and then at some point hard cut anything that would be beyond there. And the question comes for an EQ, for a what is a linear EQ, it's not a non-linear effect like a guitar effects pedal or something like that, is what exactly is it cutting out? Why is a filter required at all? Right? Because in theory, you know, this was my thought at the time. Surely, if we're just doing, you know, EQ in the audible sort of spectrum range, then there's not going to be anything to cut out. So surely all we need to do is kind of oversample, do the stuff, and then kind of downsample. But there shouldn't be anything. Why do you even need to filter in the first place, right?
Well, I see what you mean. Because we started this conversation about oversampling because of the cramping. We were trying to get rid of that issue with the phase and whatnot. But you do bring up a good point. As far as I understand, all the filters in SVF are linear filters, so they don't generate harmonics. They don't generate any sort of distortion. They don't have intermodulation. So they should not be producing audio above the frequencies that came in.
Exactly. So it's what you call a linear process. It's not a non-linear process like a guitar effects pedal, say. So that you know that gave me a bit of pause for thought when I was looking into this initially, and then I sort of focused on what it would take to upsample. So essentially, to upsample. Intuitively, you might think that, well, surely all we need to do is you know, we need twice as many samples to work with, you know, to upsample it, right? And you know, you'd think that, well, maybe the sample that's in between the others need to be some sort of average sample, right? That we can throw away at the end, because when we're downsampling, we do something called decimation, which means we can just throw a value away. Right. So the idea, so then I thought the idea was to upsample by, you know, doubling the amount of samples that we've got as it goes along. Then do the filters. Then to downsample, we just throw every other sample away. But the problem with that is you end up with a low pass filter applied to it because of the averaging. Okay. And that I spent quite a few days on that, wondering why that was. And when you actually work the math through, which again is from a few years ago, you can see why it does do that. Averaging samples is actually a low pass operation. And it turns out that the correct thing to do is to actually double the samples, but to do something called zero stuffing, which means that when you're oversampling by a factor of 2, every other sample is a 0. But you must run the filters over it all for it to work, and that will be fine. and that'll be fine when you decimate as well. However, the problem comes is that the way that works out is that it creates a perfect mirror image above Nyquist of the frequency spectrum below it.
Well, that does make sense, because if you think about just a slice of what you are doing, you have sample 0, sample 0, sample 0. And if you think about it in the time domain, you are adding a lot of high frequency energy, because you are going from a sample like 0.7 to 0. That is a high frequency kind of change. So you are introducing high frequencies in this process of upsampling, and that's why you need to filter, right?
It's a mirror image, and that's why you need to filter. That's why you need the hard cut, or the hard sort of low pass filter. So with that in mind, I implemented that. I implemented the Kaiser bezel filter, and it worked. It worked a treat. It did it. I think the only other thing that got me over is because and this was another gotcha, is that I think the if I look in, sorry, bear with me, if I look in the bit where it does this, here we go. So here's a little bit of code I left in just as a reminder, and the bit that I didn't realize was this bit there, the multiplying it by 2. And it turns out it's because there's a drop in amplitude of almost exactly 2 when it comes out, and I'm not sure. I'm just trying to remember at the time if the penny actually dropped me with why that was. I mean, like I say, somebody told me, yeah, you've got to multiply it up by 2 because you've lost half the sort of audio energy at that point. So I did that, and then everything was absolutely perfect, on the money with it. So it worked. Now,
that's fascinating. So the way that it works is you just have a stream of samples coming in, you put the zeros in the middle, then you do the filters as you normally would without oversampling. So you just do the filters. The filter part of the code base doesn't even have to know. And then you do the Kaiser filter and you decimate by just throwing out every other sample. That's the oversampling strategy in ReEQ.
Yeah.
Okay, there are other ways of doing this, and I wonder if you... Sorry, you were going to say something. I can ask what I was going to ask.
Well, I could probably just finish it up by saying, so when I first implemented it all, that was all implemented kind of longhand, right? Now, if you look at where are we? The first-hand code. Here we go, and I've kept these functions in just for reference as well. So you'll see this, for example, this function here, do fur filter less efficient. So that was my first attempt, unoptimized. So you can kind of see what it's doing in terms of what it's scrolling the window, it's putting the input in, and then it's kind of returning the affected sample by the coefficients, right? And then what it works out to, the more I thought about it, and the more I thought about the zero stuffing, it turned out that a lot of the math that was being done was actually just multiplied by 0 and then being discarded anyway. So as a further optimization step, and it took a bit of pencil and paper to work out, this is what it reduces down to, which is sort of less operations.
So I'm not sure I understand that. So you have the zeros in the middle of the samples, but then you apply the SVF filters. So the result of the SVF filters will not have zeros in the middle, not necessarily, right?
Yeah, they won't. What happens is when you run the filter code, so if we look here where the filter code actually gets run in this sort of place, the history of the filter is all being updated, the IC1EQs and all the rest of that sort of stuff. The state of the filter has been advanced, but the result that we want in the actual sort of sample window is going to get decimated, thrown away essentially. And so you can make optimizations based on that sort of knowledge, which is what this is.
So I guess the idea is that you are doing the decimation and the filtering in a single pass.
Yeah, well, I mean, the other thing that I'm doing as well. So, I mean, you know what, I could have commented this a little bit more, couldn't I? But I've put, so with zero padding, so we're only interested in the result of input 0, right? And then we're also taking advantage of the symmetrical fur filter. So there's kind of 2 optimizations in one here. And then I also rearrange the operation so that we don't need to scroll the window before calculating. Yeah. So the naive implementation kind of scrolls the window, loads the input, then performs the coefficient stuff. And whereas you can actually rearrange it so that it kind of does the coefficient stuff first without the scrolling, then scrolls the window by 2 because of the decimation, multiplies by 2 at the end, and then what you get out of the end is it's just an optimization based on the fact that you can that it's 0 padded and that it's symmetrical.
That is fascinating, and I don't think that is something that you found like on that filter design page. You don't get this kind of tricks from there, right?
No, this kind of for me, this kind of thing comes fairly intuitively. When I start looking at the values that are going through this and the operations that are taking place, and then you start thinking, well, some of that doesn't need to happen, or some of it could happen in such a way that it saves operations further down the line. But yeah, I mean, you know,
this is what happens when you spend way too much time looking at 100 lines of code.
Yeah, way too much time going. Surely that can be simpler, given that there's kind of some sort of waste in there in a way.
Yeah.
And being that we're working on, you know, in JSFX, where every operation counts, this is what it reduces down to.
Yeah, I mean, that's particularly the first obvious thing is that if you're going to decimate, you might as well not compute the samples in the middle. That is the easy part, but not the scrolling of the window is a smart move. Not sure I understand everything about the move, but it's a smart one. So there are other, again, the question I was going to get to is there are other ways of using fur and not messing with the phase. There are other ways of oversampling and then downsampling. For instance, you can do that you can do the 0 padding and in the frequency domain and then come back. And I'm sure you explored other ideas, so I wanted to know which ideas you explored and how you landed on this one.
That's a really good question. Let me, you know, I think at the time, I just might have got lucky with it. I think at the time it was either, when I was just looking at the oversampling, it was either doing it using an IIR filter and an elliptical or something like that, which I ended up ruling out, or it was doing it this way with a kind of a history buffer and for, you know, the finite impulse response. And that's it. And then all the literature that I read up was about the 0 stuffing, about the oversampling by 2, and about the decimation. I think that was it. I think that's really just all I came across at the time. I'd be interested to know if there's another way of doing it. And this is mostly the way that I've seen it done, I think, as well, since.
Sure. Right. Okay. Yeah. So let's quickly circle back to the graphical user interface and talk about, first of all, I guess it is kind of user interface, but it's also DSP. So let's talk about the drawing of the frequency responses, which is brand new.
Yeah, or well, it's kind of the insides of it are a bit new. Here we go. Let's check it out. Right, let's draw in the node. It's mentioned in a few places, so let me just get to the right place. There we go. I mean, this is as good a place as any. I mean, here's the bit of code that draw filter bands, which is responsible for drawing the filter bands in ReEQ. So I suppose the interesting thing about this, before we get straight onto the magnitude and everything that, you know, and the sort of math that's involved in that, but this kind of block that we're seeing here is potentially a disadvantage of the pseudo-object system of JSFX. Because what I've got is a loop through the number of bands, which works for most things. If you look at, you know, how that's working for the lines and drawing things and so on, it's working fine. But because of the way that I've got the bands arranged, the filter bands, I couldn't loop through. You can't loop through them with pseudo objects, and I think that's something that you've talked about in Hit On. They're just kind of explicit. You just reference them as they are. There's no looping through these different bands. There's no array essentially is the thing. They're just flat, straight objects, and you can't have an array of them.
It comes down to the fact that pseudo objects are not real objects. They are not values. So you cannot treat them as values. You cannot put them in arrays. You cannot pass them as arguments, except for a hidden feature in JSFX that allows you to pass a pseudo object as an argument. Do you know this one?
You're talking about the asterisk?
Yes. You know.
Yes, I know about that one, but it was like 2 years into programming JSFX before I saw that in some code, and I was like, what? What's that?
Yeah,
and it's like passed by reference in a way, isn't it? If I remember rightly.
It is like passed by reference for a pseudo object, but it has limited applications. You cannot put it in an array. I would very much like to put my objects in arrays, and it's not something you can do.
No, it's a shame. But no, the pass by reference thing is really quite handy, and maybe some of ReEQ's code would be a little bit shorter if I knew about that at the time instead of 2 years after.
And the other thing is, we are now talking about the graphical user interface, so we don't have to be so careful with the performance. I mean, usually when people talk about graphics, they are like, oh, we have to think about performance, but not as much as when you are doing audio.
Yeah, the audio is you've got hardly any time. You've got to be done and dusted in the audio code in a millisecond or two. I mean, that's it. That's all you've got. Whereas, you've got a bit longer to process the code for the graphics. Yeah, it's different. That's not to say you can be, completely abandon any idea of optimization or trying to be quick with it. But generally, I think with the graphics code I put in, with the audio code, I actually went out of my way to really optimize it. But the graphics code, it was just kind of okay, and it worked, and it seemed all right, seemed to perform well enough, and that was it. It was definitely a different kind of pressure.
Yeah.
So anyway, coming back, so what's happening here for all the bands to draw them all? I'm literally going through the right, horizontal range of the window, working out what the frequencies are, and then working out where those, where the individual filters responding to at that point in the frequency range. So if we go to SVF, where are we? Here we go. This is it. Yeah, so I think the last time that we talked, I said that I'd essentially done that by mirroring an RBJ cookbook style biquad with the filters in SVF, just for the purposes of being able to render them by taking the magnitude. Now, what's kind of interesting is back in the day when I first was writing that code, quite a lot of people were actually suggesting that on the KVR audio forum that, the kind of frequency response, at least from a visual standpoint, is going to be almost identical. So you may as well just use those. It's much easier to get the magnitude. And I was like, no, it's a little bit hacky, it's a little bit of a fudge. I mean, yeah, okay, it's the same. It looks the same to all intents and purposes, but it never really never really, it's one of those things as a programmer, you like things to be right, ultimately.
We are trying to find the correct answer.
The right way to do it. The right way to do it. There you go. Sometimes we take shortcuts and we do hacks and things like that, but it's satisfying doing it the right way, definitely. And lo and behold, since we last talked, I actually found the right way to do this. I actually found it. I didn't derive it. I found it.
So before we even get into that, how do you go from the cookbook into a drawing of the frequency response? That's not something that I know how to do, and I definitely have not covered in the stream before.
Are you talking about the biquad magnitude?
Yeah. Starting with the version from 2 months ago.
Yeah, I'd have to dive into GitHub because it's been kind of usurped by this one. But I guess if we do this, it's going to be pretty straightforward. I think it's actually mentioned in the cookbook document. Bear with me. Direct forms, getting the magnitude. Right, it's eluding me at the moment, but it's quite well known. I mean, there's a music DSP article from 2004 showing you how to do it.
Okay, so I guess in essence, it is you find a bunch of equations. You find a cookbook for this, essentially.
Yeah, this is it. There's plenty of references to how you do it with biquads. It's fairly straightforward, and if I went into GitHub, I'd be able to dig out the previous version. But I'm not sure if it's worth doing that.
Let's move on to the more interesting version, which is using SVF directly.
Yes, absolutely. So it turns out that all the people that, a few years ago on the forums were saying, it's actually SVFs don't really lend themselves very well to, to getting the magnitude of the frequency response. Well, they were kind of right. It's not as easy as doing it for biquads. It's not as straightforward. I think in biquads, it's just part of the, it's an easy part of the formulation. You work out a numerator and denominator feed like I think it's the poles and ones and poles and zeros in. You do the division and it kind of falls out. It's quite, as abstract as biquads are in other ways to get your head around what's actually going off, because they represent poles and zeros. It means they're actually reasonably straightforward to, work out the frequency response. Whereas SVFs, they're easier to understand in one respect, but they're a few steps removed from the whole poles and zeros thing. So let me see if now the thing is the ReEQ code that I've got that does that. Let me just get to the right thing. Probably looks a little bit more opaque than it should do, because it's using the way you do it is easiest to see when you're just dealing with complex numbers. Okay, and because JSFX doesn't natively support complex numbers or an easy class formulation, although again I think might be Tail again that did a really good complex number library that I actually looked at to decompose this into its constituent sort of operations for complex numbers. So most of what you see here is actually dealing with the imaginary, like _i, and the real part of complex numbers, and so it's a little bit harder to see what's going on. So if I sort of just bring this over, which is so where I got the derivation from, which is a lot easier to read, was this bit of C++. Okay, which handily supports is using Juicer's complex
And it's using operator overloading to make everything more readable.
Exactly. Yeah, it's a lot more straightforward to read. And essentially, the takeaway from this is that the reason why I was struggling a lot trying to find the magnitude with SVF is because you actually need the G and the K coefficients. So if we go back to SVFs and look at one of the filters, we've got these, the G and the K. Okay.
Yeah, they come from Andy Simper's papers that we looked at 1 hour and a half ago.
So the thing is, to get the magnitudes, you need those two. You didn't for biquads because they're kind of part of the poles and sort of ones and zeros specification, but they're not with SVFs, so you need them. That was the realization, actually.
Okay.
Yeah.
So
and there we go.
You found this piece of code that, given the G and the K, out comes the frequency response.
Yep. You've got it.
Okay.
But it's boiling down to doing the same thing that the biquad formula is doing. It's essentially getting back to a point where we've got ones and zeros, and then there's a divider. The arg does a specific operation on it, which is actually, is that might be, oh, my bad. I've given the it's actually this. I've given the phase response. So the only difference is essentially this. It's the apps that gets the magnitude.
Yeah.
That's it. That's the way it falls out. It means you get to a point where you've got the same sort of information going into it as a complex number division that you did after the biquads. And that's it. That's how you get the magnitude. And like I said, phase is really easy because it's exactly the same. It's just that there's this formulation. Where are we? Where it's that instead.
Do you consider adding the plot of the phase to ReEQ?
Yes. So inside ReEQ, there's the function for getting the magnitude response, and underneath it is the function for getting phase. So all I've really got to do is render it really. And you can see here at the bottom of phase there's an ATAN2, and that's essentially what the arg's doing. It's getting the angle. So here you've got the magnitude, and there you've got the angle, which is what the phase is. It's essentially the angle given a certain frequency. And it's fairly straightforward to render it as well. So it's just a case of me getting around to doing it, but that'll be in really soon. Yeah,
in that code, it's interesting. They divide by the denominator, but they don't check if the denominator is 0. A102 is doing that in JSFX, but it's not doing that there.
Yes, you can maybe only surmise that it never is, or it really shouldn't be. It's a good point. I'm not. I'd have to sort of follow through to see if it shouldn't be looking at it.
Yeah, the magic of A102 in JSFX is that it's taking care of division by 0, and it's taking care of negative numbers so that you don't get ambiguities in terms of phase. You are always between minus pi and pi.
Yeah.
Right. Okay. So.
Yeah, I think we're good. Yeah.
That's the mathematics behind drawing the curve. But let's go to maybe the where the rubber hits the road and you actually draw stuff. So let's dive into the GFX block of ReEQ, because I'm sure that there are interesting things in there, but I don't have actually specific questions. I just wanted to go over there and talk about the things that you think are interesting about problems that you had and how you fixed them.
Yeah, okay. So, right, so here we are then. I want to put a comment here, which is Beyond this point, there'd be dragons. It's fine. So the interesting thing about this is if you look at my sort of scroll bar in VS Code here, where we're at the GFX, you can see that pretty much this bit above there is really to do with, okay, and the include files working with the DSP. But the lion's share of all of the code is really, the UI and the graphic interface and handling the state of that. Now, what I will say as well about ReEQ's UI is that it's kind of it's code that's, how to put this? It's kind of grown. It's grown way ahead of it at the point where it should be systemized. It started off super simple, and then it was added to, just one more thing. So it's quite a monolithic sort of state machine sort of thing.
I love monoliths. I think they're great.
There's a lot to be said for monoliths in some cases.
Yeah.
But some gotchas as well to look out for, and you hit one almost straight away. So as we'll see a bit further on, there's a lot of work that goes into working out what to do with mouse presses, key combinations, pressing control while you're scrolling. It does one thing in one mode, another thing in another, or you stretching a box, have you got a node selected, all these different kind of states that can happen. But one of the gotchas that really snarled me up, I had to release another version really quickly, was that there's this JSFX get char call in there. Now, a couple of revisions ago, I actually thought that was unnecessary and I removed it. I thought I'd left it in for when I was doing the text input sort of experiments that I was up to. And so I pulled it out. And unfortunately, then what happens is, even if you don't get any, I'm not getting any response or doing anything with it there, it changes the behavior of certain flags that are noted with the mouse. So,
of course,
funnily enough, of course. So in JSFX, you've got this variable. Oops, let me get back to it. This variable called mouse cap, which is mouse capabilities. Yeah, it's really weird naming, and it's really, there's a load of bits in it. If you look at the documentation for it, there's a bit that gets set in it for the command or Windows key, another bit for Shift, another bit for Alt, those sort of things. For some reason, it's called mouse cap. Right?
That actually reminds me, if you excuse me, I remembered that Justin, I don't know if you watched our stream, Arya and I, last week, but Justin Frankel watched our stream together when you were on, and he answered about an undocumented variable that tells you if you are in the TCP. So you don't have to necessarily check for the size. I think that checking for the size is good enough, but there is a variable that tells you if you are in the TCP.
Yes, you're absolutely right, and I think that is documented now. I think it's been documented.
Oh, great!
I'm sure it has. Yeah, I think it's actually been documented. They still haven't documented show window by the looks of it. They've documented the flag that tells you in the TCP. So you're right. I should at some point, if it'll help. Maybe use that as well as some of the other checks that I'm doing for the size of the viewport and so on. Anyway, the point being, just to put a fine cap on it, that mouse cap thing for checking those modifier keys doesn't work the way you expect it to without calling JSFX getchar. It's just the way it works. And of course, I pulled it out and everything stopped working. I should have tested it more, undoubtedly, but there you go.
So the issue is just the first, if you don't have the getchar there, the issue is just the first time you're going to interact with the plugin if you have a modifier pressed. Is that right? Yeah,
what happens is the modifier doesn't work unless you press a mouse button.
But just the first time or every time?
No, every time.
Oh, so you would have to click, hold Command, and then drag.
Yep. You've got it.
That's good to know. That is crazy. I think that in my library, I'm probably just going to call that. Just call getchar for no good reason.
Yeah, just get it. Yeah, just get it in there.
Any downsides to doing that?
Not that I know of, no. But there's a downside to not doing it, which is that none of the modifier keys work without pressing the mouse button.
Yeah, I'll just call getchar. The same with the Retina thing. When you import my library, I'm just telling you, you are going to support Retina. I just set X Retina to 1. I mean, if you're not supporting Retina, then you probably should. So that's my answer. So I just call getchar. And speaking of getchar, you do have some, I guess, coming back to the issue of being able to input values, precise values. You do have some workarounds that you are considering, like rendering a keyboard on the screen, and then you could click on the numbers and that sort of thing.
Yeah. So what that would be like, I guess, if I show you an example of that, what I had in mind. I mean, this is something that everybody should have. Span, it's free and it's great. It's great for some things. So, for example, if I wanted to change this number there, sort of double click, and you get like a little key entry thing.
The Melda plugins also do that.
They do, yeah, they do. So you can put sort of 200 there, and that's it. That's one way of getting precise values in. And I think I'm figuring at the moment, until the keyboard thing gets kind of smoothed out, I'm thinking that's probably the next best thing to get an absolute value in. I mean, the other thing that you can do in ReEQ is you can hold Alt down, and you get a much smoother, smaller step value, which normally allows you to zero in to where you want to be.
Yeah, I guess it's one of those cases where you probably are not going to hear the difference. It's just that you want that 300 in there, not 297. You want the 300 in there.
Yeah, it's all about, OCD and not wanting 0.1 something. And
so you maybe another solution would be to just have another modifier. You have a modifier that allows you to find a precise value. You could have another one that goes in steps of 5, so you end up with round numbers, and then people will be happy.
Yeah. Yeah. See, we need the OCD key. That's what we need. That's the OCD key. Bit around, and then it'll be like 0.0 all the time, or 0.5. Yeah. That's not bad idea. So something like that, I think, between the keyboard thing that can pop up, which lets you put precise values in, and I don't know, maybe people, I'm sure people have got good reasons for wanting to put precise sort of values in, but maybe that, and like you say, the other, I mean, both of those will probably become a bit obsolete the moment that you can actually properly type values in, but yeah. Okay, so we were talking about the mouse capabilities, and can you show us the monolith that deals with user interactions? What is the strategy that you use for that? Yeah, so here we go. Well, right, for a start, there's a whole bunch of functions that are to do with rendering. This is where it renders the filter band magnitude responses and all that sort of stuff. There's plenty of that in there. That draws the grids that we talked about earlier. There's a whole load of new code that was added to deal with the new multiple node selection feature, and all of the things that can do. That was in recently new. But at some point we get past the functions and down to actually there's quite a lot of it. The actual cycle. There's definitely a lot of this stuff should be probably split out into its own include and so on and so forth. Here we go. We'll get to it eventually, I promise. Menus. Right, here we go. Here we go. Main execution loop for input and rendering. So each time round, I'm updating various filters, and then this is it. I just said about drawing things in order, according to the settings that you've got enabled or disabled.
So I guess you are going for an kind of an object-oriented approach. don't really have objects, but your functions are kind of making that. So you're extracting the portions of the drawing into functions.
That's it. So it's drawing all the things. So you can see here it's drawing the mid side, left, right, and stereo, filter responses. And then we start getting to, figure out what we're going to do with, depending where the mouse is, and like if we're in the listen mode, what to show there. So I've got an intruder coming by. Bear with me. Yeah, where was I? So yeah, and so if you look here, what it's doing. There's another menu in there, right mouse click. It's just a big old state machine, looking at mouse clicks to state you're in. Are you dragging a node? Whereabouts on the screen are you? If the mouse is within the kind of panel with the dials in. Yeah, it's kind of not really that systemized. It's kind of brute forced. So yeah, it horrifies me a little bit because I probably do most of my sort of development work in languages like TypeScript and C++, where it's all incredibly object-oriented, compartmentalized, componentized, all that sort of thing. And yet here it's just do the whole UI with a mouse, this sort of stuff.
I find it at the same time, it is very bare bones, and at the same time I find it stressful because you don't have a lot to work with, but I find it calming as well, because you can in one afternoon read the whole JSFX documentation, and there are many hidden features that are not documented, and there are many patterns that you pick up as you develop, but for the most part you can just learn it in one afternoon. So it is nice to work in this environment.
Absolutely, it's really straightforward. I suppose what happened here, I mean, I suppose at some point as this built out, so for example, things like the dials and so on, in the ReEQ panel that you can move with the mouse. I mean, it's kind of systemized. I mean, you can see various areas here where we're dealing with drawing and handling the mouse with like the frequency dial, gain dial, Q dial. In another kind of language maybe, or even in this, if it was more componentized from the offset, that'd be more contained, and you'd be just making a call to some sort of UI tree, and it'd be updated with event flags that float through the tree, and it'd all be really systemized and kind of hidden out, sort of chunked out. Whereas here it's kind of explicit. It's like, right, you're going to handle the gain dial, you're going to handle the Q dial, you're going to handle the frequency dial. You're going to handle what happens if you press the next band button and previous band button, and and essentially it could be componentized. I mean, I could actually pull that out into a purely panel handling sort of include file, which will probably happen at some point. I mean, one of the things that we could probably talk a little bit about at some point is the idea of adding things like dynamic EQ. Whereas at the moment, to add dynamic EQ, it's going to mean adding more dials and controls and this, that, and the other. I'm thinking, do I really want to just keep adding to this, or is now the time to bite the bullet and kind of refactor it and make it more component based? And
that's actually a perfect segue for the thing that I wanted to talk about next, which is right now I see that you are in the minor improvements branch, and there is also a branch about dynamic EQ. So I wanted to talk about what is coming up next. What are you working on right now, and what is in this minor improvements branch?
Minor improvements. That's what's in the minor improvements branch. There's just a few sort of tweaks in there at the moment. There's I think there's another branch I've got that's testing out a new AGC algorithm. So the automatic gain compensation that's in ReEQ at the moment. I think it's reported there might be an outside case bug with it, but I think I might have actually tracked that down. But the thing is, it kind of acts a little bit like it can act a bit like a compressor if you're not careful. So it's it can create a pumping effect if you take it to extremes, because the way that it works, it's actually calculating an RMS value for the incoming audio, and then it's working out what it is for the outgoing audio, and then it's making a correction of the difference between those two RMS values.
Mm-hmm.
So there's a bit of a delay associated with how those RMS values are collected, which again, it's okay on a sort of minor sort of subtle basis, and I think it would probably be the right gain compensation algorithm to use for something like a compressor, but I'm not sure it's the right one to use for something like ReEQ.
That's interesting that you bring this up. I have not looked at that part of the code base that is doing the automatic gain compensation, because I always assumed that it would do like some other EQs do it. I think that they Sleek EQ by TDR, Tokyo Down Records, I think that they do it this way. I don't think that they call it automatic gain compensation though. But what they do is, if you have a high shelf that is boosting, you just decrease the value a little. You lower the gain a little, because your boost is going to, depending on the program material, of course, it is going to increase the level. So it is just static. You just look at the curve and you see, oh, it's going above, so I'm going to lower the value. Or if I have a cut, I'm going to boost the value a little bit.
Yes. So it's not quite that straightforward. And there are a few EQs that kind of, dare I say, fudge it a bit like that. It's kind of a guesstimate. So if you take it, for example, the shelf example that you gave, the amount of extra audio amplitude that's going to be added to the whole signal is really, I think, going to be a factor of whereabouts in the frequency range the shelf is. So it's also how much gain the shelf's adding, but it's also whereabouts it is in the frequency range. So if you've got a shelf right at the end in a high frequency, there's not much volume that's going to be added. If you've got it right at the beginning, well, you're almost adding, it's almost like just the whole gain's being turned up for the whole signal, right?
Yeah, it's not about necessarily only the gain, it's about the area under the curve.
Yes. So my test code that I wrote, what it did in a nutshell is it kind of does it kind of goes across the frequency spectrum in certain logarithmic jumps, and it does it gets the magnitude response at those sample points, and then attempts to work out, kinda estimate wise, how much volume is being taken away by things like dips and low, cuts and so on, and how much volume is being added by like peaks and so forth. It mostly worked. It was better than some of the EQs that are kind of guess it, but it wasn't quite as good as ProQ. But it only wasn't quite as good at extreme examples. And I also thought the other day, I think I might know why that is. But that might find its way in soon, because I think it's better than the existing AGC. So this idea that you sample the frequency spectrum, or rather sample what the filter response is doing, and then work out what's being gained and what's being lost, and then compensate for that. That's the principle.
I see. So, okay, let me see if I understand this. The current implementation is more or less a compressor. Or a leveler, kind of. It's more like a leveler.
It's like a leveler. It's like an automatic leveler. Yeah.
Okay. And your plan is to remove the leveler and add instead this new idea. But this new idea, is it a static gain that you are applying? Or are you looking at the program material and seeing how much the filters are affecting the program material?
Yeah. So in this way of doing it, what you're doing is you kind of... yeah, you're right. You're not actually looking at the material that's sort of passing through. You're kind of trying to work out what you're doing to the material and come up with a kind of guess based on that. Okay.
So the old version, the existing version, is program dependent, but the new version would not be.
No. mean, who knows if that bug fix on the current one sort of works, I might actually keep the existing one in as well, and just have this new one as a variant that you can select in. We'll see how it goes.
Yeah, and I suppose that the automatic gain compensation is more for like when you're setting the EQ and you want to A/B things, but not necessarily for. You would turn it off, right? You would turn it off after you are done, because you might not want the effect of this leveler on your signal, right?
Yeah. So what's supposed to happen and what isn't happening with the existing one, as I'm not sure people are using it the way that it's kind of intended. The idea behind it. I haven't got a track ready to play, but we're talking about the AGC bottom button at the bottom there. Now, what's supposed to happen is you're supposed to play your audio through, click the AGC to start in the gain compensation, and then once you're kind of happy with it, the idea is you press the S, which fixes it, and that will actually alter the sort of volume based on the material that's gone through it.
I see.
So the idea is that you kind of get to some level that you're happy at, and then fix it in.
I see. Okay.
That was the idea with it.
Yeah, but if this new version is not program dependent, then you could just not do that. You could just enable or disable AGC, but you don't have to freeze.
No, you wouldn't. You just leave it on, and it would kind of do a good guessing job of working out what your filter response is going to do to the signal and then compensating for that.
Yeah, I guess the only case where that would not work perfectly well is if you are doing an EQ move where there is no audio, because then your heuristic would kick in, but it would be wrong because there is no audio coming through, so it's not really affecting the audio. But if you are doing an EQ move where there is no signal, then what are you doing, right?
Well, exactly. If you look at a lot of music, it's kind of flat levelish, and okay, there are places where maybe it goes quiet in the middle during a breakdown or a solo piece or whatever. But generally, it's kind of it's fairly full spectrum, and it does kind of work. I'm pretty sure that's the way that ProQ's doing it. It's a guesstimate based on the frequency response.
That would be relatively straightforward to test. Just put it through something that computes the frequency response, like the Burton EQ analyzer or even some white noise, and play around, and you see if the levels go down and up.
Yeah, I mean that's what I did.
Okay. Yeah.
I fed white noise through ProQ, and I was looking at the amount that it was increasing and decreasing by.
So we already talked about ProQ3. That's definitely a reference, and EQ8 is also a reference. What are other EQs that you politely borrow features from?
Well, yeah. Shall we say look for inspiration?
Yeah.
Yeah. I mean, this is it. Everything's a remix, isn't it? So I can definitely shout out to the DMG Audio plugins. They're totally next level as far as DSP is concerned. I mean, Equilibrium is, if you say that ProQ is like a Lamborghini sort of equalizer, then I would say that DMG Audio Equilibrium is like the top high-end Bentley or something like that. It's formidable EQ. The things you can do with it, it's pretty remarkable. So that's definitely an inspiration. Then there's another great one called Crave EQ, which is definitely worth a look. That's that's particularly good. What else? There's the Melder. Oh God, they've got about 4 or 5 different ones, haven't they, in their lineup? And then there's just so many other good ones. There's I remember there's just so many that I've sort of looked at and sort of either bought or demoed. Yeah, lots of good ones out there. But the thing is, I mean, but the reason for people have sometimes asked this. The reason for doing ReEQ wasn't to compete necessarily with those EQs. It was to give REAPER a free, almost stock level EQ that, to be fair, actually, as it stands now, is probably more advanced than any of the stock EQs you can get for the other doors. That's the kind of thing. I mean, I've looked at Studio Ones, EQ8s, Cubases, EQs, Bitwigs, the whole lot. And I think ReEQ, offers more than they do. And it's in rear pack now, so it's just a short grab away, really.
Congratulations on the repack release, by the way.
Yay! Finally. Turned out it was really easy after all. Yeah.
Right, and I guess besides being on repack and the precise inputs that we already talked about, probably one of the most requested features is dynamic EQ, and you do have a branch where you are working on that. So can you show us what you currently have and what is yet to be done?
I can talk about it. It's been quite a while since I actually even looked at that branch, so I'm not going to hazard a thing about pulling it out and seeing where I got to. It probably won't even run. So I can certainly talk about my thinking behind it. So I was mostly kind of looking at the dynamic EQ that was implemented by the Melder. Is it Auto? Again, they've got about 5 different ones. Is it Auto Dynamic EQ, I think it's called, for them?
I wouldn't know.
Yeah, I think it's Auto Dynamic EQ. And again, it's it's a great offering. And in that, you stipulate per band, you can set it up like a compressor, and then you've got the your nodes will pump away based on input. So in ReEQ terms, what's got to happen to make that a thing is I've got to take in a sidechain input, which is the signal that you're going to use to drive the compression, the band compression. Probably apply some sort of band pass filter on that, or a low cut, high cut to it to get within a variable frequency range. Probably provide some UI for that. And then it shouldn't be too bad. I think my tests, I got as far as trying to figure out the mechanics of the actual compression algorithm based on the signals that were coming in. I got as far as that, and it was spitting some values out. And then the rest of it was down to UI work and the actual proper DSP work to integrate it.
So there is no like references, papers, cookbooks, pages for this. You are sort of devising these yourself.
Yeah, absolutely. So for example, there are a number of really cool little compressor JSFXs for REAPER that you can sort of look at. And Psyche wrote a really good compressor as well, and he did reference a paper for that one. I can't remember what the paper's called, but it's kind of cool. It's in part of his source code setup. But my idea was to take a compressor that compresses in a way that is particularly appealing and useful, and then sort of take the mechanics of it, figuring out what the RMS level is, and the because all compressors doing is really working out how to decrease a signal by a certain number of decimals based on a signal input. I suppose an expander's doing the opposite, increasing rather than decreasing. But then, once you've got the signal coming in and you've got the dB value that you need to reduce by, well, in theory, all you have to do is apply that to a node, and you'd have the node pumping and decreasing by the dB amount, and you'd have dynamic compression. That's all it is essentially. It's nothing. It's not as esoteric as normal compression is. Because all you're doing at the end of the day is you're altering the gain band of a band, which is either going to be one of the peak filters, or it's going to be one of the shelf filters, because they're the only ones that have gain.
Mm-hmm.
And most of it actually isn't going to be the DSP. It's actually the UI work that's going to go into it. So if I go back to that sample here. There, so what it'll be a way of, this is the main code here that's processing the filter bands DSP. But as you can see, because everything's unrolled, because lo and behold, you can't actually loop around these certain things, so you have to unroll it by kind of default. I'm conscious about. I need to make sure that it doesn't get bloated out unnecessarily with, are we a dynamic EQ type code? Mm-hmm. I think I need to find somewhere ring fencing it off, because a lot of people won't use dynamic EQ, and there's no way that you should get penalized every sample for maybe or maybe not using dynamic EQ, that sort of thing. Mm-hmm, mm-hmm. And there's a good chance that it's just hard to prevent the code from blowing up, being that you can't actually loop or have any other kind of way of making it more compact. So I remember that being a concern at the time.
When you write these sorts of blocks of code, you always do it by hand, right? I asked you this before about that other block of code, but even this one you always do by hand, right?
Yeah, I'm old school. I copy and paste, and then I lay awake for hours at night wondering if I've forgot to change a variable name or an index number, or now I'm normally quite meticulous about it. I've done a lot of it in my time, so yeah. But you're right. I just copy it out, and then I just have to write. Okay, the next half an hour is going to be, copying it out and then making sure that it's right, and then testing it, and old school.
Fair. Yeah, one direction that I may take my work in is just write some TypeScript or JavaScript. I don't really need types for this, but write some JavaScript that spits out JSFX. I don't know.
Yeah, I mean, for example, one thing that it would have helped enormously with this, even just from a typing point of view, would be to, and I hesitate to say it, but would be to have like C-style macro sort of stuff, the hash defines in C and so on. Mm-hmm, mm-hmm. I mean, so I would have defined like one whole band processing as a macro, and then just repeated that. So it would have been defined once there with a few parameters to pass into it, and then it would just the next few lines would have been calling that macro, which just ultimately, if you think the way that works in C, it's a preprocessor. That's what it's called. It's a macro preprocessor. Yeah. It essentially, you could probably do it for JSFX. You could probably use the C preprocessor.
Absolutely, yes.
Isn't this what Grant did? He was something like that.
Not quite. He was not using a preprocessor. Well, he developed a preprocessor, but he was not using a off-the-shelf preprocessor. He kind of extended the JSFX language with some new features, syntactic sugar mostly, and then he transpiled JSFX. So there is no macro system, not even a very simple one like the C macro system, let alone a real macro system like you would find in Lisp.
Oh, that's a whole different level. The hygienic sort of Lisp macro systems. Yeah, I mean that's. Yeah. But just essentially a C preprocessor macro system would be a step up, right?
And even I was thinking about this. I was seriously thinking about this, and you don't need hygiene because there is no notion of recursion in the language. Well, you do need hygiene, but hygiene is not a complicated problem because there is no notion of recursion in the language. So if you just prefix every variable, every local variable in that scope with the name of the function or the name of the macro, if you will, then that is a good enough notion of hygiene. And of course, you don't do it with the name of the function only. You do it with the name of the function and the program point where the macro was called. And because there is no recursion, there is a one-to-one correspondence between program points where the function was called and the names that you would need to create. Yeah, so there is a simple notion of hygiene that you could implement. But I spent way too much time thinking about hygiene because I was contributing to ReEQ, the flavor of Scheme that has, it's probably Scheme, the best. Right, okay, it's the best macro system out there. And it gets interesting and complicated, but We wouldn't have to go nearly as far. It would be much, much, much simpler.
Yeah, I mean, just like I say, just even the C preprocessor would be, you know, would reduce a lot of code. But anyway, it is what it is. The point is how to stop it from becoming unwieldy, I suppose, because like a lot of other code that's get written by Psych and loads of the other fantastic JSFX developers, you know, the size of ReEQ and the sort of thing that it is kind of, you know, is pushing the edge a little bit on what it was kind of meant for, which was always the idea, you know. Well, could it do it, you know? And it turns out it can actually, you know, with a few things that could be better. But yeah.
Right. Okay, so I think it's time for us to wrap it up. Do you have more tidbits that you want to show in closing?
No, I think that's about it, really. I think we've gone through a lot, haven't we? We've gone through the you know, the filtering stuff. We've gone through the oversampling and the half band and the stuff and the decimation, and we've stared at horror at the UI code. I think that pretty much covers it. Actually, I think that pretty much covers it.
All right. Thank you very much for developing ReEQ. I learned so much from the code base, and I also use it every time. So
yeah,
my go-to ReEQ. And yeah, I'm looking forward for the new features, and maybe even other people may want to contribute to ReEQ. So there is some work to be done on dynamic EQing, and that could be fun. Or even doing the little menu. Wouldn't it be great if someone just sent a pull request for the little menu to input the numbers? Wouldn't that make your day?
Yeah, really handy. I mean, what would be great with the number input is if they expose something like the menu thing, you know, that they still haven't documented. But you know, if they could just say, yeah, you can get an input now, get the input, and it just comes back as a string that you can process. I mean, that'd just be great, you know.
Yeah, I mean, that's in essence what the component needs to do, is especially if you have some way of doing it with keyboard input, that would be great. Did you, by the way, I commented this on the REAPER forum, and I don't know if you looked into this, because if you did, then I would be interested in knowing what came out of it. The idea of just exposing the slider. If you want to input a number, just expose the actual slider.
Yes, so that's the first thing that occurred to me when I realized that you couldn't really get hold of the keyboard state focus the way that I wanted to. I thought, right, is there, now back then there wasn't a way to do it. There wasn't a way to just expose the sliders. And if you look at ReEQ, there's I mean, this is the other gotcha with ReEQ, actually. I mean, it's up to 57 sliders, and I think you've got 64.
Yes.
It'd be nice if they just expanded that out and said, yeah, you know, we'll just put it up to 1024, because the thing about ReEQ is it only exposes to the system the first 5 filter nodes, because that's pretty much all you got room for.
So the rest do you just store in the serialized block?
That's right. Yes, I was about to say that. So that's what I do. They are serialized out and then read in. And that comes with a version number in the serialization and things, so it is upwardly future-proofed as well.
Yeah, that's actually another gotcha from JSFX that is one of my favorites. If you want to have access to the number of channels in the track, if you want to have access to the number of channels in the track, in the init block, you need to have a serialized block. It can be empty, but you do need it.
Oh, okay.
It's like the get char stuff. Fun, right?
Yeah, it's another one of those. It's just the way it is. Right,
yeah, it is the way it is. Yeah, right. Okay, so yeah, you already have the sliders, and you don't show them, but you could just just for the 5 first bands, you could show the sliders when asked.
Right. So yeah. Okay. So just working that one out a little bit. So the other problem that you've got is that you could decide which slider to show. Right. If it's one of the first 5 bands, it's kind of a bit a bit limited, isn't it, if it's only for the first 5 bands. The other idea that I had was you could have just a general slider that's set aside for putting values in, right? But the problem with that is that you can't dynamically set the
range
parameters of the slider. So it would have to be a 0 to 1, which is just no use at all.
Well, actually, it can be useful because you can only slide in the range, but a cute quirk of JSFX is that you can type in any value, and it's just going to take the value, and it's going to set the slider to that value.
Of course, you could type it in. So if you gave it any range of value that you could type in.
Yeah, in fact, I probably would just say a range of 0 to 0, so you're literally unable to move the slider. It doesn't slide. And then you have to type in the value.
Yeah, I mean, that'd be one way of getting it in. Yeah, I know.
And then you take a shower.
Yeah, exactly. It'd work. Yeah, I guess it'd work. I was about to say one of the things that has never been really taken care of in JSFX is that the sliders are kind of like linear value. REAPER really needs logarithmic slider values. I don't know if you've come across plugins where it's either linear or you have to do some calculation outside and it's a 0 to 1 sort of thing, you know.
Yeah.
They're not logarithmic. And given what they are, it's like they desperately need a logarithmic slider, but there you go. Frequencies and, you know, logarithms are a big part of audio sort of parameter setting, but there you go.
Yeah.
It is what it is.
Not even just that, it would be great if you could just have ranges, right? Because when you're doing like, I don't know, the ratio in a compressor, you want more range between maybe 1 and 3, and then from 4 up, you can go in steps of 1. So you could just say multiple ranges. It could be fun.
Yep.
Could be useful.
Multiple range is good. I mean, if you look over the juice fence as well, they've got things like sliders that can be skewed and knobs and dials that can be skewed as well. So there's a certain part of a frequency range sound slider where you want it to be not have so much resolution, and then another, say the second half of the slider where you want more resolution. You know,
I think actually the Ajax library has a conversion thingy for that. I'm not sure. I know you can change the scale and the range of them, but if you can add logarithmic functions, I'm not sure. But there is a thing in the Ajax library for that.
Yeah, I think unless I'm mistaken, I think you can skew the value once you get it out, but it's about having it built into the slider.
Oh yeah.
Likewise with logarithmic, you can do what you want with a number when it comes out. So if you've got just a 0 to 1, then you can run it, you know, logarithmically turn it to a frequency range. Like that's kind of cool. But that means you end up with a slider that goes from 0 to 1, right? Whereas ideally what you want is just a slider that's just frequency, but you want it to, as you move the slider to the right, you want it to step logarithmically through the frequency range so that it's not linear. That's just you know.
Yeah. Actually, guys, I got to go. I have to leave, but I have an appointment.
Yeah, we all have to leave. Thank you very much, Justin, for everything that you did for the community. And tomorrow I will be back to my library and I'll figure out something that has to be done and I will do it. I don't know exactly what, but yeah, tomorrow 6:30 UTC, I'll be back here and continue working in JSFX. Thank you very much, Justin. It has been a pleasure.
Yeah,
you are such a great explainer and you know so much about DSP. So a pleasure.
I hope to have you back here as well and talk more about code. So
yeah, I would love to talk about the synthesizer that you are working on. And I know it's not out yet, but if you want to talk about it, that would be fun.
It's a way off. There's a lot to talk about with that. I'd be happy to.
All right. Thank you very much, everyone, for watching and for being active on the chat. And I see you all tomorrow. Bye.
Okay. Take care, all. Bye.
Bye.
Bye.